This class is called Creative Coding with Game Engines, and this is the introduction. And so let's just go through it and see how we do. So first of all, what is this course? This course is how it all finally made sense to me. I'll tell you a little bit more about my history, but I did a lot of work as a 3D modeler and an artist producing work in game engines and things like that. Fell in love with that stuff. And I've always been a relatively technical person on a certain level, but I could not get into programming. I tried, and it didn't make any sense to me, and things like that, and I beat my head up against the wall of it quite a lot of times. And it is very typical to hear people as they're learning programming speak about beating their heads up against the wall, against the concepts and things like that. So I do this from a point of sort of hope to help other people not have to go through as much frustration and mental anguish as I did, because I don't think it has to be that way. And I think that if you're already a person who likes to make stuff with your hands and things like that, that there's a very strong connection to that. So anyway, this is how it all made sense, and I'll elaborate on that more as we go. So we're just going to be looking at the Unreal Engine and what it can do, and I know that the Unreal Engine is used for making games, but I don't want to make games. I have no interest in making games. I think games are really cool and have a lot of interesting elements to them, but I want to make art. I want to co-opt that for just making trippy stuff. This course is also an introduction to object-oriented programming. So object-oriented programming is a way of organizing the code that we write that is key for interactivity. So if you look at game engines and you have the ability to go up and press a light switch on the wall and then a light turns on, or have picked up a key and then you go to a door and it'll open up and things like that. Those are examples of interactivity going on, and object-oriented programming is a way of organizing code that allows for that interactivity. I'll talk a lot more about that. This is an introduction to writing code with a C-like language using the Blueprint visual scripting system in the Unreal Engine. So there is no substitute for taking some kind of class to learn how to code. This is one of the first things I learned in my process of going and beating my head against the wall. So I finally did, and it helped me. And like I said, it took a long time, but once I got there, I really felt like it could be explained to artists more straightforward, I think. And that's the goal of what I'm trying to do. This is aimed at the artist and their maker-builder strengths and experience. I'll say this a lot more as we go. Coding is absolutely physical. You are making a physical machine. It just happens to be in the very tiny space of the RAM on your computer, you know? But you can't point your computer at a random space of memory and open it up and get anything coherent. You know, you would just get garbage. So that kind of leads us to understand that when we're working with the computer, we are actually physically manipulating things. We're setting up rows of magnetic particles on disks or whatever it is that's going on, you know, but using your mouse is a physical activity. And you are manipulating physical things. And the more that we can comprehend that physicality of what we're doing, the more that we can have a connection to it where we won't get lost, is basically the tenet of it all. And I'll talk more about that as we go, but that's kind of the core thing. This class is intended to open the door for you to keep exploring. I wish to tell you how it made sense to me so far, the key things that made me feel a lot less freaked out and more inspired, but there's no way we're going to get to all of it. As a matter of fact, I have sat down with a couple of people and gone over this material with them, and I kind of got really freaked out. I was like, holy shit. Am I really going to be able to talk about all this stuff, you know? Is it going to make sense? Am I kind of full of myself to think I can explain this all to everybody? So that's a caveat that I put out there as we're going forward, you know? And I want to hear from you guys because of how much I wanted to learn how to do this and how frustrated I got while I was trying to learn how to do this. I feel very passionate about trying to give this information. But I only want it to do if it's effective. So this is part of what I want to understand from you all is it effective, as we go forward. So this is intended to open the door for you to keep exploring, and complexity from simplicity is the kind of most important underlying thing of it all. I think the person who was here doing some of the processing discussion was talking about that, complexity from simplicity. Understanding the simple thing allows you to approach the complex implementation of the simple thing. So the point is, I want to try to get to the very simple thing that we're dealing with here and have it be very clear and known to you so that you can then move forward. And how far we're going to get through all of this stuff, I can't totally say, because I want to see what you all are, what's landing for you. And tell me if I'm going too slow. If you're like, okay, duh, come on, let's go. So that's what this program is. That's what this thing is. Here's a disclaimer. This is not a complete coding discussion, okay? I'm teaching you the things that I've used on my projects. I'm teaching you my actual experience because it's all I actually know. I really don't. There's a lot of more stuff that I don't know about. So I'm not going to try and teach you a great big, omnibus thing of it all, but I do feel very solid about what I'm talking about, and that these are the things that really made it all work for me. The Dyna Mandala is not optimized. I first wrote it in processing, actually. That was when I tried to start learning Unreal, and I would go to, there's a jillion great YouTube videos out there. In the useful links document that I have there, I've given you a whole bunch of them, and we'll refer back to that so you know places that you can go to revisit the things that I've touched upon here. I'm going to try and just touch upon things and then focus in on those real crucial concepts and ideas that made sense to me and make sure that I get those across. So if I'm going through things and you're kind of like, wait, what the heck did he say? I can give everybody the notes, and I will stop on the things that are the real ones I want you to know, and other ones, hopefully I can explain in a way that, yeah, that makes sense, enough to move on, and you're not distracted by going, what did he mean by that? So anyway, the Dyna Mandala is not optimized. This is the way it's working now. I've worked with coders who help me on Discord and things like that, and they tell me, if it works, it's good. If it works, it's good code. It doesn't really matter. There's a ton of performance optimization that's required in video games. So I'm very well aware of that, making models and having your textures have to get shrunk down and things like that. So I'm always thinking about performance and stuff like that. But I also really expect to refactor this in the future, which means to go back through and restructure the way that I do the code and things like that. So I'm also really interested, I know there are some people here who are experienced coders, would love to have a chance to talk to people who know about doing code to look at how I am doing some of this stuff and understand if you were doing this backwards, it would go twice as fast. Who knows? So since you're the first, I want your feedback, because I don't want this to just be me talking about how I know these things and stuff like that. I really want to enable people to start exploring this stuff on your own if you're so inclined. Okay, so who am I? I am Stefan Biskup. I have always been interested in art and technology all my life. I've been a musician all my life. I began working as a production artist in the game industry in the early 90s. I graduated from college. I had no idea what I was going to do. One day on BART coming home in the Bay Area, I saw an ad in the back of the SF Weekly that said, learn how to do computer modeling. And I was like, yeah, that's what I'm going to do. I never really used a computer in college, very little. There were no computers in my art school and stuff like that. And man, when I started doing it, I was a hog and slop. It's just really, really fits for what I like to do. And you'll see a little bit more of my history and where I'm coming from with this. In 2000, and so in the game industry, I worked as a 3D modeler and art director. I did a lot of teaching and training. Games are an incredibly collaborative working environment. You do a lot of teaching each other, sharing tools, talking about the best practices and stuff, because everybody's kind of trying to figure out how to get everything done, and it's kind of crazy. And so it's really about sharing information and stuff like that. I love doing that because it helps me feel more comfortable about what I'm trying to do myself. In 2000, we founded a company called Liquid Development, which is based here in Portland, Oregon, is still a going concern today, and I'll show a little bit more about that in a second. But it was really a response to the booming production needs in the game industry, as the game industry was growing incredibly, and what you could see in games was crazy, and how do you actually make all that stuff was a big mess. It's really very similar to the way that film studios got huge with MGM and things like that, because they had everybody under contract, and eventually it became really bad for the people working in the business and really bad for the economics of the whole thing. And then you had people like Scorsese and independent films starting to happen in the 60s, and the whole kind of contractor crew coming together as a group. So we really believed that that was a possible way to address this in the game industry. And so Liquid Development was founded because the industry needed efficient quality, right? But as an external provider, we had to really, really be able to nail a piece of art and have it sit next to the client's art, and you can't tell the difference and stuff like that. So a big part of my job was to figure out how we could deliver that efficient quality. I love the tools. I love doing what I'm doing here today, which is I've spent 4 years drilling my head down into this stuff, and now I'm going to come back and try and say, look, it's just like this. It's really simple, And so that's what I did for Liquid Development a lot. I would be the person who would figure out cool things and design production pipelines, and then help equip all the artists with the tools that we were going to use to do that. So that's where I'm coming from in a lot of ways. Not good at math. I actually took a college class. I took a test in college to never have to take math again. I actually ended paying any attention to math very much in like Algebra 2 when a teacher told me with reciprocal fractions, just do it. And I could not, I was like, I didn't understand it. And if I couldn't see the numbers kind of trickling through the equation, it wouldn't stay in my head. So that's the whole point of what I'm talking about here, is trying to give very direct clarity about what terms mean and tangible contact with things. Because I could always tell if I really understood some math. If I understood math, I could do it with the music on. It was just operating a machine. But when I didn't, everything had to be silent, and I would try really hard. What I really needed was visualizations. And so I think that there's a great situation here with the real-time feedback that we get from the engine and stuff that give us visualizations, and I think that we can produce visualizations with it. This is one of the things I'm really excited about gaming technology and things like that, is how it can help us illuminate topics and things like that in the future. This project that I've done, as I've said, is really very much a learning process for me. Like, how would this actually work? How could I get the things I do here to change that, and then what would be cool to do with it as we go? And I really think I have no idea where it's all going to go, and I'm really excited about that actually, because I think it's got a lot. So anyway, but programming really, at least in the Dynamondala, the math is mostly addition, subtraction, division, and multiplication. It's basic arithmetic. Just if I can turn a knob that changes the size of something, and then I can turn another knob that is an operator that's going to add an oscillation on top of that, those two just get added together at the end, right? I add the output of the oscillator and the output of what I turn the dial, and that ends up summing to be the position of an object. It's pretty much that simple all the way through. It's just a lot of them repeated over and over. So the clever opportunist, I like the idea of the clever opportunist. As I said, I've always been interested in the intersection of art and technology. I really want it to be good art, though. I don't think technology is just bitchin'. I want it to be something that makes good art. And I think of things like the clever opportunist. To me, I always use the example of the Beatles when they made Revolver, right? The new technology was stereo. And they made Revolver as they were playing with stereo. What the hell could we do with that, If you look at old animation from Walt Disney and the old Popeye black and white stuff, a lot of it are just trippy loops, you know, in the very beginning. And that's because they were going like, animation, what could we do with this stuff? You know, let's have fun. That's totally where I feel like I'm at now with this whole process going forward. And so I'm still learning. I don't want to spend too much on this, but I also think it really will help you understand where I'm coming from, so I'm going to spend some time on it. So what is my approach? I have a healthy disrespect for computers. They are useless without the instructions that we give them. They are just a stupid box of metal and rare earths that get electrified and can be really useful. But I think that the deification of computers and everything like that can actually really get in the way of what we can do with them. I love using computers. I think they're great. I work with them all the time. But I also, like I said, I didn't have any computer classes in college, so that kind of gave me a good arm's length from them, I think. And so I try to just communicate that sense of appreciating them, but also, you know, putting them in their place on a certain level. All art involves technology, okay? Knowing how to hold a pencil, knowing how to mix paint if you're using oil or you're doing watercolor, if you're doing acrylic, whatever. Knowing how to get just enough water in the watercolor, having just the right brush you like, that when you dip it in there and you start to paint, it's a freeing experience, you know? It's a technology that you're so well versed in that you can start to be expressive with it. If you hold up your thumb and you measure how far something is as you're working on drawing, that's technology. Okay? So I want to become as adept with code to wield it expressively. That's really what I'm doing. Where I'm personally at now is the Dynamondala works pretty much. I'm adding some new features to it. I'm on to 2.0, but I really want to mess with it more now. Like just getting it to work is kind of where we're at now. Making cool stuff with it. What can I do with it? Where can it go? And things like that, just from an art point of view, is sort of where I'm at right now. So yeah, all art involves technology. The idea that computers are somehow unique should be stricken. This is why we should have the, you know, disrespect for computers. So we can just see that they're a tool, just like any other one. And they have their things to learn about them, and we've learned other tools in our art practices before. Real-time 3D is a valid medium. Real-time 3D is what games are, okay? And interactivity is unique. Personally, my experience with doing the SETI show and doing the Dynamondala for the first time was to actually not complete everything I intended to, not show up with this elaborate, beautiful art that I could get you all to sit down quietly and fold your hands and watch, but actually the interaction and the completion of the piece by the people playing with it, that was just incredible, you know? And so every medium has a unique hook to it, right? I mean, books, film, radio, all the ones that have really been substantial, and music and everything. And I think that interactive real-time 3D has its own hooks to it. I don't play games very much. I don't have time for them. I don't have the attention span. I want to work on my code instead. But I do think that they are a medium, they're the next medium of humanity in a lot of ways. Not games, but interactive experiences and the things that we can do with it. And there's so much we can do with it. It's still evolving. And I love that it's capable of extreme weirdness, right? Like we've been working for 40 plus years now in doing video games and trying to do photoreal graphics, right? And it's really good. It's unbelievable how good it is. And what I think is neat about that is that I can make something really realistic feeling to you, and then I can start fucking it up, right? And just making it weird. And you'll see, I'm a surrealist at heart, and this is what I'm after. Complexity from simplicity, okay? Everything that we do in the computer is a very simple thing. It's just the computer can do it a lot and really fast. And harnessing that is to really harness the power of the computer. I use this example here. This is from one of the first games I encountered when I started working in video games at all. And it just shows a simple door and key mechanism. Well, a door and a key is a very simple example of what's called a Boolean variable. which is one of the things that we're going to deal with in coding. It's one of the most basic variables that we have as our data types, and it just says true or false. And so in the code, you walk over a key, and a Boolean inside of your character gets set to true. The has key gets set to true. So now when you walk up to a door, the door will check you, has key, yep, okay, you're opening, right? Or not. So it's just a Boolean operator being used to generate, and the code you need to sort it up. But then, let's add color to the equation, right? So now you're looking at this example, and you see we've got the key and lock thing, but now we've got colors, and now we've got the ability to make a puzzle out of it, or a better puzzle out of it than it would be if we just had one key and one door type, and you just went around collecting them and doing that. That is a perfect example of what we're actually doing when we code. You know, we're using simple ideas, and we're being clever with the usage of those things to make more interesting interactions. That's what's super fun and kind of crafty about the whole thing. Yeah, okay. So complexity and simplicity. And the other thing is, the more essential your understanding, the less things you have to remember. Right? Like let's try to get to the most simple thing, because we can't hold all of these details in our brain that are going on in this stuff. And so as you understand the simple things, it makes you able to follow things of greater complexity. So more about me, my interest in technology and art and things like that. Here's a little bit kind of recounting my history leading into this. Disneyland. I grew up going to Disneyland, the Haunted Mansion, and Pirates of the Caribbean. I would go home after. I remember one time my dad explained to me the way they did fire in the Pirates of the Caribbean, which was to have this sheet with light hitting it and then just blowing a fan up it. And when he showed it to me, I was like, holy shit, that's right, I see that. I went home and built it in my room that afternoon. Yeah, and I made haunted mansions in my house. I had strings on the tops of doors you could pull and stuff like that. You too?
No, I'm just delighted.
Okay. So that's a big influence. I think video games are really theme park rides. A video game level is very much a theme park ride, like when you're going through the Haunted Mansion graveyard and things are popping up at you and stuff like that. Same stuff. And it's interesting actually now how much real-time 3D has become a part of, or video playback has become a part of theme park rides as that technology has been adopted. Godzilla movies. I loved Godzilla movies when I was a kid. Really what I loved about them most was I could tell that they were miniatures that they were stomping on, and they were so badass. They were so well made. They had such attention to detail. They were such great, interesting art, right? So I love, one of the big things about liquid development that I used to always tell people is that we're not doing fine art. This is a craft. And that means that there's rules. That means there's things that we can understand and work against, instead of just, we're just dropped in the middle of like, make something meaningful, So I like craft, I like quality, I like detail, I like precision. These are all the kind of things that I expect generally are what buzz everybody when they're in a wood shop, cutting things to the right size, measuring fabric, stapling it together. You know what I'm saying? Yes? There's the lining. Okay, cool. Monster makeup was a big early inspiration for me. I grew up when Universal Studios was ever a thing in the first place, and you go see the demos of the monster makeup and the stunt fights and all that kind of stuff, and I absolutely loved it. And then surrealism. Okay, whoops. My computer is chugging just a bit, but we're going to be fine. Okay. And surrealism. Like I said, I like that we can do weird stuff with all of this. I like making weird art. Now, specifically, though, about these two people, this is Salvador Dali and Rene Magritte, both of whom I've actually later got to see their paintings up close. They are fantastic painters. Not just good, like fantastic. So what I loved about these guys was not just that what they were showing was trippy, but it was that they did it so well that it didn't just become surrealism, it was like super realism, right? I believed what I was seeing in those places. And so for me, again, this underscores the idea, I love technology, I think it's great, I love craft, but I want it to be good art first and foremost. And I love learning the technology and spending a long time on getting good at it, but I really don't like it when technology is too forward. You know what I mean? There's sometimes when people do stuff, anyway, I don't want to talk about negatives too much. Let me move on.
That was a rabbit hole.
Yes, thank you. So an additional early inspiration, I was thinking about this, and this is so true, was recording studios. As a kid growing up, like I said, I didn't grow up with computers in art school and stuff like that. So I grew up hearing about the latest badass recording from Led Zeppelin, who was in this multi-track studio, and Pink Floyd and all these other kind of things, you know, and this was the high-tech fetishism of our time. This is before the internet and everybody had PCs and all this kind of stuff. And you'll see how interestingly this rolls into Blueprint and the programming language we do. And then it just, to me, it just informs where I'm coming from in a lot of ways. So also, I love guitar pedals and sonic inspiration, or sonic experimentation. I like to make weird noise music and just stretch sound like taffy and all this kind of stuff. And guitar pedals and you can be plugged in lots of different ways, and trippy stuff can happen, and it's all about experimenting. And you can see how it's sort of similar to what we see here, but it's a little bit smaller. But these days, modularity is everywhere. So up here is Houdini. Houdini is a very famous program that was kind of one of the first ones to start making a node-based scripting system become popular in computer graphics. Houdini is used for a lot of the simulations in disaster movies. One of the reasons that we see so many disaster movies these days with these exorbitant, really detailed, crazy things going on is because of Houdini and its power to procedurally generate things. You don't just make a scene and say you're going to do it. You have all these nodes that you can manipulate as you fine-tune. It's what's called non-linear, meaning that you're not just laying it down. You can go back and mess with it when you see how it looks and stuff like that. That's coding, too. Okay, so if we look over here, this is a program that I used in audio called Reason, which is mimicking the model of the rack that was from the studio, and it actually has, you can see here the back view of it, it actually has wires connecting things together and stuff like that, just like guitar pedals. I've used Reason was the place where I first really started getting into using physical MIDI controllers, so I didn't have to have a mouse and tweak little dials. I could actually have knobs here and play it like an instrument. This is totally the through line for what the Dynamandala is. This is Blueprint. This is actually the code here in Unreal that is the Dynamandala. We'll look at it more. So you can just see this modularism is everywhere. And it really is like plugging in guitar pedals. Like this one's going to be a transform, this one's going to be a rotate, this one's going to be a color change and stuff like that, you know. We'll look at that more as we go. Yeah, now, early career again, I said this already, I didn't have any computer classes in art college. Nobody used computers hardly at all, but and then I started at this place called the Computer Art Institute. My first computer I bought was a 386, I think. It was before video cards, before a lot of that stuff. There was this Mind's Eye video series that was out, that was some VHSs you could see and things like that. And then there was also Mondo 2000 in the Bay Area. I was living in Oakland, and this was in the 90s, this cyber futurist magazine that was talking about internet culture coming up and everything. So I knew vaguely about computers and things like that. And then, like I said, I just one day saw this ad to go learn, and that was off. And it wasn't even that big a thing at the time. And I was just like, well, this is going to get bigger. If I get involved now, I'll be a part of it later. And that's how it turned out. So again, as I talked about, Liquid Development was founded in 2000, and I've spoken about a number of this, that we really needed to be efficient quality, and that was a big part of my job, was to figure out good ways to do things and come back and help people do that. And what I think was funny in looking back at this is a portfolio of work that we did that I used to, show to people, but it's so funny to me as I was assembling this, how when I look at that early inspiration stuff I was talking about, I really did it all. This is the kind of stuff that we did when we were making stuff for games. This Batman stuff, and my kind of specialty was characters, high-end characters, because that was the funnest stuff. And so I focused on that a lot, but I also, all these projects were things I had a hand in. Yeah, so you get an idea of the sort of things that we did, monsters and creatures and vehicles and weapons and world building, setting up, these are all the different kind of services that we did, and animation rigging. This is probably about as technical as I got. So one thing to really understand about 3D characters is they are not sculptures, they're puppets, right? Like if you don't have the bones placed in the right places and you don't have the anatomy solid and things like that, a beautiful sculpture could be ruined by weird proportions when it starts to animate and stuff like that. So I have always had a pretty technical bent, but again, had never really done coding. This was one of our coolest projects that we did was the Beatles Rock Band game a long time back. And this was before there was much in the way of what we do now with modern shaders, reflections and things like that. And so in this game, we totally hacked a way to do reflections on the surface where I'm not going to say all the technical terms because it'll probably be more problematic than beneficial, but it was a really interesting project in the way that we got creative with something that was not really what it was supposed to be. If I try to talk about it more, I think I'll be more distracting, so I'm just going to move off of that.
What software were you using?
This was with a company called Harmonix, and they had their own game engine. We created all the assets in 3D Studio Max, mostly, and then it was in their game engine. It had to do with the reflections on surfaces, and that if a reflection is more blurry, it will feel like things are more matte, and if it's sharper, it will feel like they're more glossy, right? And so we had a way to control the blurriness of the reflection maps. And we actually sat down before we started the project and said, okay, what eras are we going to show? Because what we did in here is we made all the instruments and all the outfits. They did the heads because they had Beatles, on their backs, making sure it was just right and everything. But we did the hairstyles. We did everything except for the faces, essentially. And all the instruments. Like we had Rickenbacker writing us and telling us that, we needed to have TMs on all the guitars. Even though the textures were so low resolution, you would never see them. So we sat down with pictures of them for all the eras that they were going to be portrayed. And we figured out a formula for wool and for patent leather and for plastic and for nylon and all these different things that had to do with setting that blurriness of the reflection. And we made formulas for it all. And this was before people really did stuff like that. Now that's pretty much what the architecture is. So I feel good about that. And it worked. It was a bit of a crazy idea at the time, but it totally worked, and it gave us the ability to do very nuanced separation of what the surfaces looked like in a very simple way. So it's always about looking for the simple solution, I think. Okay, so that's about me. That's about where I'm coming from, and that I'm art first. So let's keep going here and talk about what is programming, okay? So programming is talking to a machine, right? Sort of. In fact, when we run our code, it's more like remote operation. If I could sit down and have 20,000 arms and move super fast and move a mouse and grab this thing and put it over there and start that thing turning and do this manually, I would. But I don't need to because I can write a script that the program will read and follow the instructions to do that stuff for me. That's what coding is. Coding is remote operation. In this case, when people are doing physics simulation and high-end math and all that other kind of stuff that people do, but I'm not doing here, maybe that's a different example and that doesn't extend as well. But especially for what we're doing here, it's mostly remote operation. And again, as I was saying before, Blueprint is coding. It is a different interaction, and you will often hear it Blueprint is the system within Unreal that we're going to use. And you'll often hear it talked about as coding for artists, but don't take that as meaning it's a simplified version of coding where we only give them the part with the training wheels, because it's not. It's everything. It's variables, it's arrays, it's loops, it's conditionals. And that's all you need to know about programming. No. Okay. The process of designing and writing a set of instructions. Okay, so what is programming? I kind of wrote these like, ask the question, here's the answer. What is programming? It's the process of designing and writing a set of instructions, your code, to be art when these instructions are carried out by the computer. What is programming? Programming is breaking a task down into its subtasks, into its many, many, many subtasks. And this goes back to the point of talking to a machine, right? The machine does not accept any metaphors. It doesn't get your vibe. You have to tell it exactly what you want it to do. And the thing about that is that it's kind of grounding, right? Because it is a mechanism. You can know exactly what it's doing. There's no point at which you're kind of going, I wonder what the computer's thinking right now. Does it feel like doing this for me or not, you know? It can seem that way sometimes when we're dealing with it, but in fact, it is not. And most bugs are typos. Essentially, the computer always does what you tell it. It is exceedingly rare for hardware to fail, and that's the problem why your code isn't running. It's usually because you just don't know what you told it. And it will repeatedly do exactly what you told it to do, and until you get down and break down that task, you won't really know what you said. And it's almost always a typo. When I was first learning and things weren't working, I imagined wonderful stories about the many, many things that could be going on and stuff like that. And I found that most of that was just stress and my mind going crazy. And usually when I sit down and just start to get focused and go step by step through it, oh, I spelled something wrong. Oh, I'm not going to the right array. You know, oh, I didn't connect this one to that one. I connected it here, you know. So, and I mean that to give you a sense of comfort with the idea. Ideally, I'm getting better at this now. I can sit down and instead of going like, I want to destroy my machine now, I go like, okay, sit down, take your time, we'll figure it out. That's a growing skill for me. What is programming? It's, once you break it down into tasks, it's designing algorithms to carry out these tasks. So a set of well-defined instructions performed sequentially to complete a task. So, and it's often called logic. So as I said before, the math that I do in here is really rudimentary. It's simple addition, subtraction, multiplication, a little bit of trig, but it's actually, you just need to learn one thing. But putting those all together is in logical ways so that you are doing this task and then that task and then that task and not out of order and things like that. Or I'm going to make a conditional that says, if it's like this, do that with it. If it's like that, do this with it. It's more of what I do in coding, is figuring out the sequence and how to get a reference to the thing I want to talk to and then send the message to it than it is about math. And then finally, what is programming? It's combining these algorithms, our logic, into a functioning system, the art. So what is the Unreal Engine's visual blueprint visual scripting system? Okay, so it is a schematic representation of C++ code. It is a library of nodes, of the objects that you use to link together that provide the core C-like functionality, the ability to do loops, the ability to have arrays and things like that, these things that we'll understand later. So we make functional code by assembling these nodes together in chains of logic. The blueprint editor presents a strong visual organization of an object/actor's recipe or class. We're going to come back to this term class. Class is one of the terms that screwed me up for a long time until I heard people use it. And finally, now I can tell you what it is. It's going to be great. So the blueprint editor is a way of making objects. We're going to talk about object-oriented programming that grants us the ability to do interactivity, and that's what blueprint is meant for, is for writing objects. And you normally would write them in this particular way of doing text that can be really hard to follow, and this is better for artists on a certain level, but it's not training wheel programming. I just really, really want to make sure that everybody understands that. So the blueprint editor presents a strong visual organization of an object's or actor's recipe or class. There are two parts to an object or actor's recipe, and that is data and functionality. We're going to hear these terms over and over again, okay? Data and functionality. Data is the variables and the components that go into your object. Data is the 3D mesh for your object. Data is the color of your object. Data is the position of your object, the size of it, the rotation of it, and is mostly interacted with in the details panel. Functionality is the code. Functionality is the fact that if I walk up to a visual 3D model of a light switch and I get close enough and something pops up and says press this key, that when I press that key, I will be running the functionality that's inside that light switch that makes it animate up and then turn a light on, right? So that's the functionality. The visualness would be the representation of the switch, and the functionality would be the fact that I can interact with it. And there are three primary areas: the construction script graph, and I'm going to show you these in a second, which is basically for making things in the world. For if you're, it comes out of the games. Remember, we're doing games. If people are making a game and they're making a town and there's a guy you can go buy, you know, wares from, and a place you can go get a quest from, and things like that, you're going to place all these things in the world, and maybe you want this guy to have the model of the blacksmith and use the blacksmith interaction logic, and this one to use the spells or whatever. So setting all that up in the engine, you'll take these objects, these interactive objects you make, and have the ability to set things in that as you build out the world. Then there's the event graph, and the event graph is the code that functions when you run your project. So with the construction script graph, you're in the world, you're setting variables, and that's what we're going to mostly do today. And then with the event graph, that's when, if I hit a button on this, it sends a pulse that then tweaks a variable and assigns it to the particle system that's up here. I'll tell you more all about that. And then the viewport is something that's in the blueprint editor that allows you to look at your thing as you're assembling it. So, and we call the code files that we create blueprints. Okay, so it's the blueprint language system. We've heard the class, we've heard actor, we've heard object, and we've heard blueprint, and they really are all the same thing. Different terms for same thing. I'm going to go over those terms a bunch more and really knock them home for you. But when I say we're going to have a blueprint, that's the file that you're writing your code in, that you're putting the data in and building all of the stuff with it. So here's a picture of it again. Now, this is what I was saying. We have data, which is the variables and components that are listed over here. This is where you add a 3D model to it. This is where you create variables that you're going to drag out in here and use as your code. Will be coming, you know, and things populate it. You can create things in here and then they populate over here. So this is kind of your menu of all that stuff. Now, over here, more data is the details panel. Whenever you select anything in here and it's got elements to change about it and things like that, that will be in the details panel. This idea of the details panel is also something that exists in the main editor. You're going to see this over and over again, this idea of select an object, and now here's the details panel where we can adjust variables, various things about it. And then in the center here is where our functionality goes. There's actually 3 tabs across the top here, and they represent that: construction script, event graph, and viewport. And we'll look at those directly in live operation soon, but I just wanted to give you that basic thing, okay? Okay, so why are we discussing this? So in my opinion, the divide between artists and engineers is somewhat artificial. Creating a coding is a lot more like making art than many may realize, and I really mean the idea of cutting things in pieces and sticking things together and putting them over there. I mean, it's basically a virtual soundstage. I always liked, we would talk about the idea that the problem with computers is gravity, and the problem with stop motion is gravity. Because in the real world, if you're doing stop motion, you have to figure out a way to get things to float in the air, right? Armatures and things like that so that they can go flying through the air and everything. In computers, there is no gravity, so you have to keep things to make things not look like they're floating, you know? I call it floatomation when you see bad animation that's just like weird and mechanical looking, you know, and doesn't have life to it in computer graphics. But they're very similar, the worlds of working in the physical world and the world of working in the computer. In fact, almost everything in the engine is a metaphor for the real world. We place objects in the world. They have spatial locations. We place lights in the world. You know, it's really, the more you can think about this not as something on the computer that does something I don't know about, but like embrace this is a virtual sound studio where I've got infinite supply of materials and stuff. That's the way, except for, you know, there's the performance of your computer and how much it can run all at once and stuff like that. But anyway, getting it really to feel physical. So coding is building a machine. I think I already said this maybe. You know, usually it's obscured by the fact that that machine exists in such a tiny space that it's on a chip in your phone, you know. But in fact, if we could zoom all the way in there, there's levers and pulleys and pushes, and it's a totally mechanical thing. And the more, if you're not already given to having code make sense to you, the more that we can have that knowledge of the physicality of it all, I think the more that it will stick and we can build upon it. So that's where that's what works for me. You know, that's what works for me. Why are we discussing this? Because the tool set is amazing. And it's totally synchronized. I mean, we didn't set it up today. We didn't have the time, but I can do quadraphonic sound in this just by telling my computer to be set up to quad, and in the world of the engine, placing sounds in different locations. And it'll do all of the mixing of that into the quadraphonic system, into a 7.1 system. And, you know, I'm not going a lot bigger than that with custom speaker arrays and things like that as of yet, but I could. And I just think that, as we'll see, we're going to look at some specific features of the engine as a way to begin getting into understanding coding more too. And I think it's an incredibly powerful tool set that I want to get more people aware of what it's capable of. Simplicity is deep. Again, complexity from simplicity. Why are we talking about this? Because a computer is really just a fancy 20 questions machine. All it does is says yes or no. But instead of 20 questions, it can do 20,000 questions. You know, it can do it so fast and so much that it's more than just, you know, the pedantic understanding that 20 questions would give us about something. But have you ever played those little phone apps that do the 20 questions? Like legitimately? Everybody know what 20 questions is? Are you all familiar with this? Okay. There's computer apps of it on the phone. They get it every time within 20 questions if you're just thinking of a thing and it starts doing it. I mean, it's a very effective way of working, and that's you know, true about the computer as well. From few core components, complexity of software of all kinds is created. And that makes it comprehensible. That's the important part about all of this. That simplicity is deep, is that we can understand this stuff, and it's not as overwhelmingly as we often hear about it. So, terms. Making peace with techno-jargon. Coding is a language. You have to take time to learn it. There's no getting around that. Terms can be a barrier or a key, and that's one of the things is I want to really talk about the terms that were barriers for me and give you the key that opened it up for me. Part of that impetus for me was to be pissed at all the videos I watched where people kept using terms that I didn't understand. And so I was like, F this, I'm going to teach people how to do this so it's like sticks and rocks and it's really, really easy. But the truth is that technical language means that somebody who knows about coding can have a conversation that is substantive and real about code purely verbally. Can't tell you how many times I asked somebody a question on Discord and they spoke code back to me and I didn't understand it because I wasn't that well versed in it, but it was actually extremely precise and it is very empowering. And so, you know, you will be happy once you start coding for this specificity because it allows you to get help from people. It allows you to find the answer to things and stuff like that. But there is a hierarchy to it, thankfully. So you don't need to memorize and there's documentation. You don't need to memorize every term, and I'm going to try and really focus on the hierarchy that can then make it possible to branch out into the more complex stuff as we go. The aim of my class is to highlight what key terms were critical for me opening up my understanding of coding. It's about the best I can do. I don't know exactly what's going to work for you. Let's try. So finally, code thoughts. Computer languages are much simpler than written or spoken languages. It's probably why we call it code, right? Because it's not really a language, or it doesn't seem like it when we try to read it. And of course, machines, these are machines. They require us to be explicit and exact. It will not understand a metaphor. With a limited vocabulary and grammar, you must get clever, right, in order to do things. But the cool part of it is that you can get clever with such a limited tool set. I actually am glad there isn't more in a way, because I can focus on being creative with the things that we've got. So simplicity is deep, once again, okay? All right, so back to this introduction, just kind of recapitulating what we're talking about here, then we're going to take a break and get into some actual manipulation of stuff. This course is how it all finally made sense to me so far, what I know so far. This is an introduction to the Unreal Engine and its basic but powerful elements for neat art. It is an introduction to object-oriented programming. That is the core for creating interactive experiences. It is an introduction to writing C-like code language using the Blueprint visual scripting system in the Unreal Engine. It's aimed at artists. It is intended to be the door to open, it's intended to open the door for you to continue exploring, and complexity from simplicity is what we're always going to be trying to talk about. So now it's break time. But does anybody have any questions so far on that? Is it all making sense? Does it seem clear? How's it feel? Was that too much? Was that good? Does that seem all relevant? Yeah, good? Okay. All right, cool. Thanks. Okay, so we're going to take a break now. Thank you very much. And there is a disk, there's a hard drive, a little thumb drive that has files that, yeah, there you go. And so that thumb drive, go ahead and let's keep getting it around to people. How did people do, does everybody have the engine installed?
I have it 63%.
Okay, keep going. How many people did the tutorial? Excellent, that's perfect. Okay, perfect. The first time you start a level in the engine, it has to do a whole lot of caching and stuff like that. So start the engine. If you already have the support file, it's a zip. And if you unzip it, it's an Unreal project file. If you haven't started the engine at all yet and you're still installing, finish getting it installed. If you have started the engine, and if maybe you did the tutorial, then you would have created a project and had a place where you put your project files. So that zip file should be dragged into the same place. There's a hierarchy of the project file and then stuff that goes inside of that. So there's just a place you need to copy that that you want to be able to have your project on. I won't say more than that because once it's in there, we can start it up, and we'll do that once everybody's got it. Here's the folder. That's the zip file that we got, right? Unreal, SETI, third-person base. So if you open that up, I'm going to actually close this now so that we don't have that in the way. You open that up, and then there's this file right here, project file. Double-click on that, and that should start it up. And when this screen comes up, you see down here it says 80% initializing and stuff like that. If this is your first time starting the program, it may take a significant time longer because it has to build cache files and things like that. So that's fine because we're not going to start using it just yet. I just want you to get started and have that beginning to get going in your system so that when we do start doing hands-on, it'll be there for you. The goal today is to go through the engine and get you real comfortable with some basic concepts about it. And we're really going to get into the nitty-gritty of names of things and stuff like that about programming more specifically tomorrow, but we will be touching all of it immediately in the process of doing this. So, this section is called Game Engines and Real-Time 3D in the Unreal Engine. What is a game engine? So a game engine is the whole ball of wax. Basically, it's a self-contained software system built to make games in. It used to be that everybody wrote their own game engines, and that's a huge source of inefficiency in the game industry. Things like Unreal and Unity and Godot and all these there's many other engines out there. The whole idea of sophisticated middleware rising up to be able to help people with making games is very real now. When we first started making games, it was like we were designing the camera with every game that we made. Film has had for a while where they've had more stability in their technology, but it's always changing nonetheless anyway. But there weren't game engines when we first started. There weren't these robust environments to get into and start messing with. And these game engines have just recently gotten even simpler to use. I don't want to be a salesman for Unreal and nerding about its features and things like that. It is the one I use. I don't use Unity. I've hardly ever even opened Unity before. People do great stuff with Unity. I used 3ds Max my whole career, and I would talk shit on people who use Maya, just like Maya would talk shit about people who use Max. And it's all just really what you're comfortable with. People are good and can do a lot with all these different tools. So I don't want to be too much of a fanboy for tools, but at the same time, using the same tool regularly is how you get good at it. So knowing a lot of tools is not necessarily as important as knowing some tools well. I think that Unreal is the most artist-friendly experience. I've been using it for a very long time through very many different versions, but most recently, they've added features that make a lot of the mundane preparation of data kind of things less crucial than they used to be. You can use lights and very heavy objects much more freely now, which used to require a whole lot of preparation of data and things like that. So somebody who's comfortable with the idea of being in a photo studio and using bounce cards and having lights and all of the things that you would do in a real studio situation, that is extremely relevant knowledge now. They have elevated the metaphor and the workflow of Unreal to a point where it's much more forgiving around that, or much more relatable. So a game engine is really, it's about input, which is, here coming from the player, going into a system, and then response happening out of it. If you're messing with the Dynamondala, you touch a pad, that's input, that starts some logic in it, and we get the results visually that's in response. That's all it is. It's just fancy different ways of doing it upside down and backwards and inside out and things like that. How do you use a game engine? So it's very similar to other digital content creation tools. People call it DCC, especially 3D apps like Max or Maya or Blender. You've got a 3D space. You place objects into the world. You can put characters into the world, lights, animation, sound, all of that stuff exists within the Unreal Engine, is at your disposal to mess with and synchronize. How do you use the Unreal Engine? Interactive objects can be assembled to create interesting mechanics. So this goes to the idea of having a light pole that you can walk over and there's a switch on it, you can turn it on and off. Or a door that you can walk up to and open, a vehicle that you can drive. Video games are really, they embrace object-oriented programming intensely because it's a really sensible way to think about things. It's also very performant, meaning that you don't really start using computational power to do what the logic is inside that object until you sort of turn it on by interacting with it. So always with what we're doing, we're trying to work in real time. So there's always about trying to make things more efficient and how can we be clever about doing it. And so object-oriented programming is very what they call performant. It performs well. It has a reduction of the load of CPU that allows us to dedicate to other cycles to make our frame rate. So a game is really an assemblage of all of these objects, and we can leverage this for art. That's the whole point. Here's what you're seeing. Like, I could be talking to a character and buying a loaf of bread, or I could be turning knobs and making lights flash and having the Dyna Mandala. It's really the same thing. So in Unreal, these interactive objects are constructed using blueprints or C++. Blueprint is C++, just in a different visual representation. In Unreal, these an actor is the name for these things that we place in the world. Actors, objects, blueprints, they're really the same thing. You could get detailed about defining them, in their application a little bit more broadly. Blueprint is actually used throughout the engine in various other systems as its whole method of programming. We're just looking really at making objects and interacting with them and stuff like that, but it's pretty ubiquitous throughout the whole system. So actors or objects combine data and functionality. We talked about that earlier. I'm just going to say that over and over and over again until it really sinks in. Okay, so going back to more of the points we talked earlier, coding is remote operation. What you do manually while using things in the engine is automated when you run your code. That is far too simple of a statement. But it is not a bad place it is a good place to start, especially for interactive art like this. Having a strong grasp of working in the engine manually, I think, can help us when we get into the more abstract thing of writing code that is going to execute these things that we would typically do with clicking and dragging and stuff like that, okay? So we're going to look at using the engine for clicking and dragging and some of the cool things that are neat about the engine for us to be able to mess with, some of the things that are part of what's cool about real-time 3D and video game engines' effects and capabilities, with the idea of seeing some of the variables that are in it and stuff like that and creating a really strong connection to what we'll be then doing with code as we go forward. There's some helpful resources. Okay, so there's that creative coding with game engines. I didn't write the whole thing. Useful links needs to be on here. Anyway, there's that, I was telling you about this Word document with useful links for you to go exploring further. Here's this viewport navigation, like you hold the Alt key and you can, this was included in the material that was when you first signed up for the class, so you should have this. And this is just really good to know for ease of use as you go forward working in the engine, this set of shortcuts and stuff like that. Do people here play games very much at all? Are people already familiar with first-person shooting and WASD and stuff like that? Yeah, to a certain extent? Okay, cool. So you'll be familiar with a lot of these if you are. If not, it's not that hard. So Unreal project structure. Just a general kind of idea to see here that there are these levels that we've got, right? The project is just your whole thing. It's that project file we clicked on. It's the entire, everything that's there. Levels are, like a video game level. We're gonna play Mario level 1, and when we finish it, Mario level 2 loads up and things like that. You'll also see, though, that levels are a way of segmenting something into other parts. You'll see a little bit of this as we start to mess with it. Levels and sub-levels, those are ways of organizing the world that you're creating. Unreal is a world-building tool, okay? It's meant to build worlds that are, that you would then turn into a game by adding all this logic and coding into it. So levels and sub-levels are for helping to organize that as you work. And specifically sub-levels, actually this is a thing I can go here, I have words with it too. Sublevels allow you to break it into subsections so that you could have somebody, say, work on the lighting while somebody else is working on the texturing, while somebody else is working on the trees, while somebody else is working on the enemies or whatever, okay? So sublevels are not something that I get into too much on my own. I do have levels as far as, I don't know if you saw that when I push a button, it'll move from one configuration of mandalas to another, and that's using what's called level streaming. When you're playing a video game, the whole world is not loaded into memory. As you progress forward, certain parts are getting gotten rid of and other parts are loading in the effect of giving you a seamless progression. And so I am leveraging that stuff to basically construct scenes and then, have that scene and you can interact with it and play it. And then I can hit another button and go to a new scene and you can interact with it and play with that. And right now I can only flip-flop between two scenes. But I have actually, in the new version that I'm working on, created a more of a round robin, so I can just keep adding new scenes. And that was one of the big things I wanted to fix after SETI, was trying to make a robust designing and kind of scene building system. And so
you're doing that as levels instead of sub-levels.
Yeah. And I'll show, you'll see where we turn them on and off. It'll make more sense. So again, below that, in the sublevels, are the actors. We've talked about actors and objects and blueprints, right? These three things are all, just think about them as the same. This is the interactive objects that we can place into the world. The Dynamandala is a particle system. Particle systems are generally done for explosions and special effects, and usually it's like a bomb goes off, and then all of a sudden all these sparks fly out or something like that, right? That's a lot of little things moving in space. A particle system is really specialized for making those things move smoothly, for checking back on them every frame and updating their position and stuff like that. It's a whole kind of unified system for doing that. That's where I ended up with Unreal for performance reasons. So in fact, I have a blueprint that receives the input from MIDI. That's a central root. And then I have other blueprints that have the particle system in them that are the objects I place in the world. And the root keeps track of those objects in the world. And when it receives MIDI information, based upon other variables I have set, it will either go out to that one, or go out to that one, or go out to all of them together, or we're going to be just the one that's about manipulating colors and stuff like that. So, but right now we're just going to be looking, that's advanced, like once you've figured out how it's slow doing it other ways is. The idea of the input, routing of that input, manipulation of variables, application of it to the things in the scene. That's it. That's all it is, and it's just in different ways and stuff like that. So the actors are those things that I place in the world, those dymans. I really got into this idea of it was a dynamic mandala, so I've just pushed this name thing. I call that the Dyna controller, and it's the dynamic palette, the Dyna palette, and the Dyna mandalas are the objects that are sitting in there and stuff like that. So, okay. Another thing to know is that I am actually dynamically generating the color palettes that you see on there because I'm red-green colorblind. And so I will mistakenly choose yellow when I should choose green, or green when I should choose yellow, unbeknownst to myself. And so I actually created a system where I always choose harmonically sound color combinations. And then I can mess with it beyond that and everything. But that's another one of the actors that I have in this world. So there's the root actor that receives all the MIDI. There's the Dynapal, the dynamic palette that does the palette generation, and then there's the dymans, these objects in the world that have the particle system in it that get the base seeds from the Dynapal and then generate a number of values for however many objects there are in that spiral layered stack. And I can manipulate the colors beyond there. Does that make sense? Is it clear? We're good? Nobody's too confused? Okay, cool. All right, so then let's look a little bit more at just overall what's going on with a game engine, okay? So rendering is what we're doing every frame, right? We basically, all computer graphics do this. They do rendering. The big thing about game engines is that they do this in real time, right? So they are looking at the world, looking at all this data out there, and generating a flat image. It's really, this is what we're seeing right here, is this flat image. And how fast and that's a frame. And it just basically, just like we saw when we were doing processing, and you have the draw loop that is basically all of the calculations that happen to create a frame and then put it to screen. And that's a heartbeat that is kind of there, the draw loop firing over and over again. That's what happens here. It just goes through and it executes all the logic and creates a screen. And so how fast it can do that is the frame rate. The camera is usually our head looking into the world, right? Okay. So now let's I want to show some working in Unreal now, so I'm going to try and multitask the screen, and I hope that this isn't too distracting. So here again, when we talked about levels, here's some of the levels that I was talking about. If I go and turn off SETI demonstration, those will hide. If I turn on scene design, so there's one of my mandalas, right? So this is a level that I use actually for setting up a scene. This is my newer version of it. A lot of it's not working at this moment, but gives you the general idea. And then I've got here scene 1, scene 2, scene 3. I can keep adding more scenes, and as I build those, then I've got this queuing system that will load them in as I go between. But once they're loaded in, they're ready to receive the information. There's this central thing here, which is, this is the spline that the camera flies on as it moves around as part of the whole camera system. And I can manipulate the spline handles, and I change the curvature of the path that this can fly on. So my idea ultimately right now, it just does this cool swinging back and forth. I wonder if it would come on right now. I'll actually show you my new camera system. I'm really excited about it. This is one of my, this is one of my blueprints. I'm not going to try and have this make sense to you, just to give you an idea. This is the central one that I can set what the edit mode is. I've got system edits here. It's routing MIDI data that's coming in, MIDI CC controller in, and it's deciding here, is it going to edit the layers of the mandala? See, it's called layer edit, or is it going to edit the palette? And anyway, just not too long on that so it doesn't get confusing, but that here allows me, remember the details panel I talked about? So here's my script in the world, my blueprint in the world so that it's active. And then I have these variables here, which I need to set this. I think it said 4. Let me double check that. Yeah, BCR is 4. Okay, so this is, I've got something that reports to me where it finds the MIDI objects, and I have to set these right. So 4, there we go. Now this should work. So I've got this knob that I can turn, and this is just basically changing the progression along that spline. And I just hit a button I shouldn't have hit, and I messed myself up. This is not the greatest MIDI controller that ever existed. It's given to some faultiness. Behringer is really known for how cheap their stuff is. Huh? And so, there, okay. So, but what I'm really excited about, now I can select different cameras and I can just load them. Oh, there's something that's in the world. And jump between these cameras. But I actually have the ability also to animate between the cameras now. So that's a really exciting new feature. I originally wrote this because I didn't know what size the art should be to make a mandala, and I wanted an interactive way to try building it and have however many around and what size, and just as a way to start figuring out what should the art size be, what's the right thing, and it just blossomed into all of the rest of this. I've used this charting schematic program that's called Draw.io from, it's a Google thing. Anyway, you can see in here that so MIDI uses what's called CC numbers, continuous controller numbers, to identify which knob is being turned, that it comes in. So as a message comes in, it says what its value is, and it also says which one it is. And this is an example of how I have these top rows have modes, and so they actually The first mode is 0 through 7, the next mode is 8 through 15, you see? And so this is how I set up what the controls are. And there's more controls down here as well, and the buttons and things like that. So when let me turn that off. So you can see the MIDI messages coming in and telling us what controller it is and such. And so there's just like the position XYZ, the position XYZ, the radius, the size of the objects in it, the rotation rate, a twirl offset. And I have this other, I like this feature. If you see in the middle here, it says 0.001. So I have this knob that'll control the granularity of my adjustments. And so I can go, if I go to 0.10, or if I go to 10 and I start to do the radius, I get more significant. I keep bumping that size one. Shoot, that's funny. And here's the thing. Once I have the ability to manipulate this and get it to go, that also means I can code it, right? So part of the prototyping here, and then I've got alternate versions. So this one just is sort of an increase of the, anyway, all of those things are parameters within the Dynamondala that I address through the controls, and this is a way that I can know where they are instead of just trying to have it in my head. Okay, so let's talk about what the basic things are in the engine for the purpose of getting our head around all this. So if I go back out here. So here we have our world, and this is just like kind of a basic setup. And so the first thing I want to talk about is just how do we know where things are in the world? Here's an object, and I can grab it, and you can see I can grab these handles to move it on different dimensions. If I grab this square here, I'm moving it on both of these dimensions, you know, okay. Now, if we look over here in the details panel as I do this, see these three numbers will change as I manipulate this. See that number changing as I move it back and forth? Yeah. Okay, position and stuff like that. All right, so this is ground zero. This is the coordinate system that is used to figure out where things are in the world. And we use X and Y like we would typically use on graph paper, but if we're doing 3D, we add Z to it as well, okay? So, and the important thing to look at this is that as I move this thing, this number changes, or it varies. Variables can be varied. You hear about variables a lot in coding and stuff like that. Variables are things that you can change. You change them through your code, but what they are is very tangible. They're not abstract. This is these are called float values because they have a decimal point, so that we are able to have very discrete positioning of things rather than chunks of 1, 2, 3, 4. Okay? Sometimes there's other variables called integers that are whole numbers, and we'll look at those more, but just see that there's basically 3 float values representing the X, Y, and Z location. There's also you can kind of see the axis changing here. I should probably put a cube in here for examples of rotation. If you wanted to, if your engine is running and you would like to start messing around with stuff, I welcome you to go ahead and do this. I'm just starting up the same project you guys have, so there's no difference. So if you wanted to, you could go down here and click on this content again. And if you look down here on the bottom is this folder called starter content. This is a bunch of stuff that Unreal gives you to mess with. And in here, there's a folder called props. And we can just start grabbing things and pulling them out into the world, like this chair, or this doorway, or this sculpture, whatever, right? These are just 3D models that you can drag out, and all of them have a coordinate system. that says where it's at in the world. And if you look in the details panel, you can see the numbers. And you can also do, this is why I wanted something that wasn't a circle, you can see it also does rotation and also scale, which, there we go. There's a little bit of scaling, okay? Again, these are along the x, y, and z coordinates. Okay, so the x, y, and z coordinates. Now, continuing on, there's also what is called local and world space coordinates to understand. So, and you can see this little row of settings. See how that's a planet, and this is an object, right? So this is local space, and this is world space. World space is where is something in the world, right? This is aligned, it's always aligned that way. If I switch it to local space, when I do that, and let's say I rotate this thing so it's not aligned to the world, okay? I hit the F key to zoom in on something. I hold the Alt key and click in the view, and I can drag and revolve. This is on that tips sheet that we were talking about. So now we can see that this thing is not aligned perfectly with the world, and that really becomes useful if I then take now the local coordinate system. I can have this chair move up that way, right? And so this allows you to have things, you know, fly along their trajectory, if you will. Over here is this little arrow that lets you reset things to where they were to start with. You'll see this all over the place. This is a way to get back to where you were. And if you imagine, let's say this was a plane going along and you wanted it to do a barrel roll, right? Like this. That's easy when it's aligned to the world, but if all of a sudden it's turning this way and it's climbing up, you know, to the sky, if we were in world space mode and we tried to do that barrel roll axis, then it's going to, see, it's rotating around an axis that's aligned to the world. Whereas if I go into local mode, it's got its own axis and I can do a barrel roll with it, see? You can change back and forth between that. You'll do local manipulation. You'll set local, set world space. So setting the position of things, setting the orientation of things, setting the scale of things can have two different modes that you do. And we'll look at that a little bit more. But that's understanding that. And it's like, you know, just the fact that left for us is unique personally versus, you know, describing a place in the world that, you know, that building's on the left, or that, no, north is really relative, you know, north isn't, there's no north in space. Huh? The origin is that axis, is that object, okay? So yes, and these are just meshes in the world. These are not blueprints yet, okay? So this is placing objects in the world, and every object has an origin point that you would set in any piece of software or something like that as the starting point of it. That's a great question you asked, because that goes right into my next point, which is, well, I should say there's another location in the world, another origin point in the world, which is your player start position, okay? So, do people have the engine running? Do people want to follow along with this part here? Sure. Okay. So if we go to our world, and you look over here on the right where it says World Settings, and you see Select Game Mode. So over here on the right, do you see the World Settings tab? It may not be, if it's not there, then go look under Window and find World Settings, and you'll pop the window up. You there? Yep. Okay. Now see, it says Game Mode Override None. Switch that to BP Third Person Game Mode. Let me make sure I do have a player start in here. Where is that thing? There it is, okay. So this is your position in the world. So I've got third person going, and now if I hit play, here I am, I'm in a third person game. There's a character, and I can use my mouse to orbit around them, and I can use W key to walk forward, S key to go backwards, left and right with the A and D. Okay, so this is standard first-person navigation or third-person navigation in a game. So that player start is the location you're going to start in the game. That's your position. I want to also show you something, though. This says third-person default pawn, right? Basically, the point I wanted to say is that if we were able to look at that character, it is a blueprint. We talked before about objects and things like that. That 3D model is in there, and there's a camera that is behind the character, right? So this is the idea of kind of a base architecture of input and response. It might have just been hidden behind, I don't know. So back to our notes. Your position in the world is by the player start, okay? So that's important to know when you want to start making things. Now notice that what I was showing you earlier, we chose the third person as our default pawn. Click on that and set it to actually default pawn instead of third person character, and I'll make sure that I open up the map we want open so I have parity. So here's this world, and I go ahead and I set this to third-person game, but I set default pawn is what's here instead of BP third-person character, because BP means it's a blueprint for the third-person character. It has that mesh in it and the camera and stuff. If you just do default pawn and now you hit play, then it's just like a regular camera, right? I'm using the WASD keys to move around, and there's no character in front of me and stuff like that. So this is what I used for a long time with the Dynamandala, and the fact that it sits on the spline and I can move it around and stuff like that, that's a blueprint I created that specifically sets the camera on a spline and gives me all those other controls. But the point I am trying to make to you here more than anything is that you have a 3D position in the world, XYZ coordinates for objects that are there. You yourself have a 3D position in the world that is defined by the player start. When you are then running the game, input is data from connected hardware, a keyboard, a mouse, a MIDI controller, a gamepad, an iPad, whatever that you want to use. And pawn is a thing that can be possessed in the world and controlled. Okay, so the basic structure of playing a game, and I only say this because this is also the basic structure of putting a camera to see your art going on and be able to adjust it and things like that, is this. You have input. Input gets used in a lot of other things as well, but in this specific thing we're talking about it. And the pawn is a thing that you can possess, and the player controller. Controller is a kind of software you'll hear mentioned many times that is basically the software that makes a connection from the input of your hardware device to the pawn that you can control in the world. Does that make sense? The pawn is the thing you control. The controller is the interpreter between that, and the input is whatever you're using and whatever you set up. Okay, so what are we placing in the world? The main thing that we're placing in the world a lot of times is meshes, right? In any 3D package. And so you asked earlier, Pam, about the origin, right? The origin is the base axis of the thing in the world. And then all the points that make up that 3D model have positions, XY coordinates themselves, but they're relative to that base location. Right? So it makes it easier to transform an object in 3D by grabbing its root and moving it around, and then automatically the rest of the points come with it because it's a single object, right? And they're, you know, a 3D object is made by points that are then connected by edges that define surfaces, and then we have 3D surfaces in the world to be lit and to receive light and to see actually there. So let's just quickly talk about types of meshes. There's almost everything we're going to do here is with static meshes. Static meshes mean that the points never change position relative to that axis. You can move it around and it's a rigid object. If you want to have the points change, then we're talking about something like a character, where you can bend the arm and have the geometry deform around it and the shoulder and all that other kind of stuff. So that is what's called a skeletal mesh. So there's static meshes, which are just objects in the world, And you can change their color and do all kinds. All the objects flying around the Dyna-Mandala are static meshes. Skeletal meshes are when you want to do animated stuff. And I've done Dyna-Mandalas made out of skeletal meshes. It's possible, but the frame rate's even worse. But just knowing that difference between the two, because you'll hear these brought up. If you wanted to do animation as part of your stuff, you would be using skeletal meshes that could take that on. And then there's lights. Lights come into the world and allow us to see stuff. So let's go ahead and look real quick, again, back at our world. I've got this level called Light Demo Setup. So you can open that up, and now all of a sudden we're going to see a little bit of... So one of the things that's really neat that I was talking about before, when we talked about that the lighting in the engine now is much more relatable to a standard studio environment and things like that. It used to be that if you look at this room, the light source is mainly these windows, right? But there's actually light bouncing off that wall and illuminating us this way and bouncing, and creating all this ambient bounce light going on. It used to be in video games that if you wanted that effect, you would sort of make a light over here and then you go place some other lights over there and place some lights there and try to mimic bounce light effects. That is now with Unreal 5, they have real-time illumination really dialed in. So we've seen grabbing objects, throwing them in the world, the idea of them having a position. So we can also, I'm just going to go down here, and if we go up here under this, quickly add to the project, I can see under the lights category, I can grab a point light, and I'll drop it in the world. And so now we're seeing some illumination going on in the world. I can adjust its position, moving it around, and so this is just like a 3D object, but this is an object that is spitting out photons so that we can see the surfaces in the world. I don't know if you did the tutorial, but it is possible to turn this off, and now we've got nothing. There's no lights in the world. And actually, I want to make this my current level. There we go. I'm going to turn that back off again so that we can see the world is totally black, right? This, now I'm going to go ahead and I'll grab another light. I'll use a spotlight this. There we go. There's a little bit of a spotlight now coming in the world, right? So this is a light that can have, more of a cone kind of thing, right? So we saw that there was a point light. I could go over here and grab a point light. So this is just a round sphere emitting light into the world. Now see how this bounce light is starting to happen?
Because we're in a room now. Right.
Because I built this room box around it. I built this box for us just to be able to see these lighting effects. And you see the way the illumination is happening here. Actually, if I go and I turn on this one here, now we've got this guy who is also interesting in that, and this is all in your level if you want to mess with it. If I go down here, you see this emissive boost. Oh, is this going to work right now? Let's see. I better turn the world lights back on. So here's the world lights. And actually, if I turn off the lighting grid and see there we go. This is the one I wanted. Turn my light demo back on. Put this guy inside of there. The point is, this idea that we have objects in the world, right? And that we can put into position, and we've got lights in the world that send photons and hit the surfaces and light everything up. And I know that we're going to take a break now. We're back. Let's carry on here. So we left off looking at placing things into the world, seeing that we have numeric values that represent the location, the rotation, and the scale of the object. And then also looking at lights in the world. I touched briefly upon the bounce lighting system that's built in there, and hopefully we'll look at some more coolness about that as we go forward. But what we want to talk about now is a little bit more about rendering and what are called materials. So this is getting into something that will help us understand the way of setting up elements within the engine to be programmable, to be spoken to by the code, to have variables that can be adjusted with the code, as well as a good introduction into node-based graph building and using it as a programming kind of paradigm. So let's first start here with 3D meshes and looking at this model that's here. And you see on the left, there's flat shading and then there's smooth shading. So if you look at that, the flat shading, you can see the edges between the pieces of geometry that make up this model. And that's because those are just basically shaded constantly, meaning every face is a solid value. And now if you look at the sphere to the left of it here with these little lines pointing off the surface, okay, those are normals. Normals are vectors or directions in space that are perpendicular to a surface. So you can see down here there's a normal up and a normal down for the surface. Or if you look at that sheet here with those points coming off the center of the faces. The idea of a normal is a really good thing to understand. It gets involved with more complex materials in the future, but also the important thing to see here is that obviously these normals here are pointing at a little bit different angle as we go around, right? They're all just bristling out that way. And in the process of rendering, they say, okay, there's a light up somewhere here in space, and here's this object, and which way is that normal pointing towards the light? And that becomes part of the way to understand the orientation of the surface and therefore what color the pixels of that surface should be. Now, if you look at the smooth shading, what's going on is that they're actually interpolating from one face to the next. And so that normal isn't just a single value of the center, it's sort of an interpolating value as we go across. And so the point of that is that in the rendering process, there are multiple passes to achieve the final result. We're going to massage the data, essentially, as the light is coming down and hitting the surface. Many times, normals will get used in this. But what that is called is materials. So materials are basically a term you'll hear a lot of times. You'll also hear the term shader very often, and we just got started, you're just fine, okay. We're talking now about the way in which, I'll show you this really quick, Pam, since you just got here. This idea, you see you've got faceted shading and smooth shading here, and there are these normals that are coming off this surface that are the orientation towards the light, and when you interpolate those values, you get smooth shading. And the idea of something that is going to work off of the surface and process that surface and the way it responds to light. That's what a material is. It's also called a shader, and it is a small bit of code, okay? And we'll compose it in a tree that we'll see in a minute. But so it's, the reality is when we're in the world, that light is coming down and it's full white spectrum and it hits our skin or our shirt or our glasses or whatever, and certain parts of that light get absorbed. Certain frequencies of that light get absorbed and certain of them get bounced back, and that's why we see color on an object. In fact, a surface is a light filter in a way. It sucks out all the things except for whatever it reflects. And whatever it reflects, it becomes that color, okay? So this is about how light responds to the surface is really important to think about. The programming we're doing is of the surface. We use the term material because it is more than just the color of things, it's also its roughness or its metalness you see here. So in the latest version, there's actually a new shader model coming, so let's all get our brains scrambled up for the next round, but has been the standard for a while is what's called physically based rendering. And that is really thinking about the idea of individual photons coming down and bouncing off the surface and where do they go. And if you look here, this would be a very perfectly smooth surface. And so you see the light comes down and it reflects back out perfectly, right? So when you have a perfectly smooth surface, you get mirror-like reflections in the surface because the light is not being scrambled as it bounces off. When you have rough surfaces, like you see it over there on the edge, it's what we call this is the microsurface, okay? This isn't as big as ridges and things like that. This is like the quality of why my shirt is actually reflective. You know, your sweatshirt, anything that, you know, you just see illuminated is actually reflecting. It's just that because its microsurface is not mirror-like, you don't observe it as a reflection. You just observe it as illumination. So my glasses are very smooth, and so we see, you know, reflections on them. But my skin is rough, and so we just more see, you know, fall off of light across the surface. So physically based rendering, and there's a billion different parameters, not a billion, but there's a lot of parameters in materials and things like that. But for the PBR system, the core thing is the color, the roughness, and the metalness. And so let's look at that now a little bit more. Now I'm going to go ahead and pull up the engine here. And I invite you all, if you've got it open, to go ahead and follow along if you want. Here's a thing to know. Here's an object. If I hold down, like I can move it, and then I hold the Alt key when I do it, and drag, I can make a copy. And I'm going to also open up the content browser. Within our SETI class folder, there's a folder called Materials. Okay? So I'm going to take this material, and I'm going to grab base material 1 and drag it on there. It'll take a second. There it is. I dragged it on there so we can see it, but I'm going to also open it up. And so here we go. Actually, let me just do this really quick for the sake of following along. If I were to, now I'm in the empty space of this area, I'm going to right-click, and then I'm going to choose Material. So I'm making a new material file right now. So there we go, and I don't care what it's called, I'm just going to call it that. But when I open it up, this is what it looks like, actually. Okay, so there's none of those things connected to it. I can right-click here, and now you see this is the beginning of exactly the kind of stuff that we're going to do. This is an introduction to node-based and graph building. This is very like Blueprint is. Okay, so this is the material editor, which is kind of the first place where they really had these graphs installed. It's the first place I got used to it. And it's also, materials are really neat, and you can do a lot with them, so it's good to know about them because they're very good for leveraging for making the art stuff. So getting hip to materials is a very, very powerful part of the 3D world to know. So I can right-click here, and these are a whole bunch of different things that I can grab to use. But what I'm going to do is this. I'm going to hold down the 4 key, and then I'm going to click. Hold the 4, and then click, and it makes this right here, which is a constant 4 value. See, there's 1, 2, 3, 4 zeros right there. If I open this up, we see there's 1, 2, 3, 4 zeros there. Red, green, blue, and alpha, which is generally transparency. I can click on this and get a color picker. Double click on it, and I can choose colors. And now as I do this, we see these values, red, green, and blue, moving, right? So each of these values is a float variable, meaning it's a decimal point variable, okay? And many times in our code, we will create a single float value that we use as part of what we do as our calculations. But there is also a very common practice of assembling those rudimentary variables into larger structures because it's a common way that you're communicating. Going back to the idea of variables and float value or an integer value, The reason that there are those two is because at some point in time in early computing, it really mattered if you were going to need a decimal point for how many bytes you were going to need to be able to define your value, you know? So float and integer, I mean, I could almost use a float for everything, right? Using integers, I do at times when it's smart. They tend to get used for counting and stuff like that. But it really kind of, the idea of the separation of the two of them really has their history more back into the way of optimizing data flow. And so same thing with color, right? So a color has the red, green, and blue values. If people have worked in Photoshop before and you know about channels, you can look at the red, green, or the blue alone, and it's actually a black and white image, you know? So the red, green, and blue channel are identical. They're the same thing. It's just that in the software, the values of the red are going to the red phosphor or whatever it is. You know what I mean? But it's this assembly of the values together into one unit. They call it a 4-vector here. There's 2 vectors, there's 3 vectors, and there's 4 vectors. And that just means there's, you know, 2 floats together, 3 floats together, or 4 floats together. So the same thing with like X, Y, and Z that we were looking at. There'll be a location in space will be your X, Y, Z values. A color will be your RGB values. Again, though, those are all just floats that are being stored together because it's convenient. You're always going to want to give a location all 3 at once, right? You know, so it really has more to do with the pragmatism of making things optimized. And there are many different ways in which there are conglomerate values that are, you know, made of these rudimentary variables going forward. Make sense? That's why I hit 4 when I clicked down, because I knew I was going to get a 4-value constant. I could also click 1 and click down, and now I get a 1-value constant. So if I take the output right here and I put it into base color, now I get the color, right? So this is sort of the place we're feeding all the data, and this is the result of it. So now we've got color, and there are some default values for these two. As I said earlier, we have metal and roughness are the 2 really important ones. So I've got this 1 value here I can drag into roughness, and that value is 0. So now we're seeing a perfectly smooth sphere. And that perfectly smooth sphere starts to get reflections from the world around it. If I take it, you know, to 0.2, that didn't work. 0.2, typing really well here. 0.2, there we go. 0.2, please. There we go. So there are a number of different shader models that you can choose from. You can see here these things, but actually I should go additive and things like that, but there's also, if I stay with opaque, I can go here, and there you can see eye, cloth, hair, skin, stuff like that. These are all specialized versions of the material targeted at the things that are needed in those specific applications. Right now, we're looking at the most basic shader, the most basic physically based rendering setup for the sake of ease of comprehension, as well as, you know, clarity of the idea of making the graph and having it adjust stuff. So we see that if I change this value here, right, to 0.5, it gets even more faint. I can change it to 0.8. I can change it to 0, or no, 0 is glass, and if I change it to 1, that's as rough as it can be. Okay? So here's also a really important concept to think of, which is normalizing of a value. So this value goes from 0 to 1. And that's a standardized practice a lot of times, is making values go from 0 to 1 is called normalizing. I won't go a lot more about that right now. Just hear that word and we'll come back to it. But you can see that each of the RGB values, if we click on it, goes from 0 to 1. So, well, you can go farther, and that has to do with the fact that materials can be overdriven, but basically at 1, we're at max red. If I bring this up again, 1 is maximum red, right? It can basically go from 0 to 1. And blue, you know, and green can be from 0 to 1. You can move these 3 sliders to each other. But this idea that from minimum to maximum is from 0 to 1 is what's called normalization. We'll run into that more in the future, but it's also true about these things like roughness and specular. So I'll set this back down to 0.2 or 0.3, which is kind of a 0.3, sorry, which is kind of a standard, you know, plasticky looking thing. And then the other one that gets mentioned a lot is called metallic. And if I drag off this, now I typed before and I made a 1, I've done different things. If I drag off that and then I let go, hold the 1 now, I just hold 1 down and then I click. And it's really, if I go to constant and I say constant, there it is, same thing, right? Okay? So now, so this is at 0, okay? This is the metalness. And what this is the difference between metals and everything else. There's fancy terms, there's dielectric and conductor, I don't know what all else. But anyway, the trick with metal, if I set it to 1 now, which will be fully metal, the reflections in the surface start to get colored by the surface. So when, you know, basically that's the deal. Metals colorize the reflections and non-metals don't. You almost always will go between 0 and 1 for metal. Even though it's got a variable there, it's generally going to be a non-metallic surface or a metallic surface. The one that gets more variation will be this roughness, and then of course the color, okay? So those are the 3 core principles, and there's a whole lot of other stuff here, and shaders can be insane. Shaders are amazing, and a whole life's work can be spent programming shaders and using them. But the important point what we're looking at here is the idea that we are just sending numbers down a wire to a target that give us our results, right? So this is the core of graph-based programming. We're creating this graph that functions as we go. Okay, so we've seen this idea that we have nodes, we have wires, you know, and we have in and out points that we connect these together. So as I said, you can have extremely complex shaders that do math and will do distortion of things. You can, you know, as you look through things, it'll have index of refraction. You can do rim lights based upon the vertex, the orientation of the surface and things like that. Materials are a great place to start to get into interesting, complex, and fun manipulation. They're also very, very deep, and they can get, I could show you some stuff, but I don't have that material prepared, so I'm not going to bother. But anyway, they can get, but the Dyna Mandala uses very, very simple materials at this point. I actually do have built in to it the ability to use the roughness and the metal and some other stuff, and I'd love to get fancy materials on the surface because, actually, I should say that if you go into the content, oh, I see what's going on. These tabs can be dragged around into separate windows, or they can be docked like this on here. So if we go back and look at our level, and just a little, this is not even very sophisticated, but down here in the starter content under materials, there's a whole bunch that they have, and you can get an idea of all the different kinds of surfaces that can be defined through the use of materials. So there's a lot to it. I'm not going to go down that hole because I want to first get back to the idea that what we've been looking at just now has been a solid color for the entire thing, right? So that's cool. We can see that we have this nice simple model that allows us to define the way the light reacts with the surface. But sometimes we want to have more discrete control of the surface instead of having it just be one color. And so textures allow us to do that. We can wrap images onto surface so that now essentially every pixel of a color texture map becomes that 4-value slider for the color at that spot on the object. So basically, a texture map is almost like a sheet of those variables, of those float values, right? The way that you associate the 3D surface with the 2D surface is through the next 3 letters of the alphabet before X, Y, and Z. So X, Y, and Z are your positions in space. UVW, X, Y, Z, UVW are the coordinates that are on the vertices. So the XYZ position, every vertex has an XYZ position relative to its root, right? And then it has the UVW coordinates. That is the way in which the vertex gets associated into the 2D image. If we look over here on the right, we see this idea of taking the cube and slicing it up like we would if it was made out of paper or something, and spreading it out flat onto the surface. This is called unwrapping a model. What's really important here is if you look at this right here. This is the flattened out sphere. This is the image on that sphere. You can see the relationship between these two roughly. So this is in your level. If we go in here, and here's that Earth dude. Here's the first one. So if you look up here, it says selection mode. If you click on that, you can go down here and choose modeling mode with that object selected. There is a really good 3D modeler now in Unreal. Actually, I've used it. I'm getting to use it more and more, and it's quite robust. I'm using it now because I don't want to be distracting by us jumping out to Blender or Maya or something like that. This is just a really straightforward thing. But I'm going to scroll down here into the bottom and find the UV subsection. And then I'm going to click on the UV editor with that selected. And this window comes up, and it shows us these are the vertexes of it. And if I move this around, we can see that texture on here. I'm going to click here so that I select vertices. It's vertices, edges, faces, some other stuff. And now up here, I'll click on this. This was the pointer for selecting. And now this is the grabber for moving. And if I move those around, now you see I'm dragging the points and their relationship to the 2D image. Okay? So is that clear? That makes a lot of sense? Yeah? So this is how we get the two related to one another. An important part about UVs is that they are normalized values as well. Up here is 0, 0, 0, or maybe down here is 0, 0, 0. Up here is 1, over here is 1. That's the maximum of the map and the maximum of the map. This map could be any shape. It could be any resolution. The vertex data is stored as a value relative to the full size of it. So a point, the vertex at 0.5 by 0.5, if we made it a 2048 by 2048 image, if we made it a 512 by 512 image, that vertex would always be in the center of the image. So this gives you the ability to change what the resolution of the map is without having to affect the way in which the model is drawing the information from the map. So I'm not going to save that, no. So now, these are some of the meshes that are used in the Dynamandala. These are doing something else, which is instead of using them to put more detail on the surface, the UVs here are being used to split the mesh into different regions of the texture. Okay? In this case, the texture is really just a mask. And if you notice, all the parts that are over the white area are white, and all the parts that are over the black area are black. And this was just something I came up with as I was looking at, mandala pieces, and they had black outlines on a lot of them, and then they'd be colored, whatever, in between. So you get the idea that the UVs here are putting parts of the mesh to be drawing from particular regions of the image, right? So if I now go into here, I click on this guy. And in the details, here's something to know about the Unreal Engine. Here's what mesh it's using. Here's what material is assigned to that mesh. This is information about this object in the world. When I want to be able to deal with that stuff, right here is this little icon of a folder and an eyeglass. And basically, that's going to help me find where that asset is in my drive of material. So right now, I've got that thing selected. I click on this, and it shows me in the content browser, and you guys have all this stuff in your level too, where the material is. And if so that now I can double click on that and open it up. And now we see this is a more complex tree than what we were seeing before. But what's actually happening here is a form of what's called a conditional. In code, you have evaluations. Is this value greater than or less than that? Is this true or false? If it's true, then we're going to do this branch of code. If it's false, we're going to do this branch of code. So conditionals are a really important part. This is a special kind of conditional called a lerp, which stands for linear interpolation. And so this lerp is basically getting this black and white image in here, okay? And so based upon, this is the alpha coming in. Alphas are typically we saw that with the color, that there was this alpha at the bottom that is oftentimes used for translucency. Alphas are very many different applications of alpha. So alpha is kind of a generic term for a data component of a value, if you will. And that alpha is telling us, and actually if I put my mouse over this, it'll tell us stuff about this. And if you see it says hold Control and Alt for more. So this will tell me more about this node. So you'll find this a lot of places as you're working through both Blueprint and the material editor. Rolling over and will give you more information about stuff. And this is saying that basically the linear interpolated expression blends two input values based upon a third input value used as a mask. If alpha is 0, the first input is used. If alpha is 1, the second input is used. So 0 is black and 1 is white. Somewhere in between will actually blend between these two surfaces. Lerps and blending with alphas, you can do some sick stuff with that in the material editor. But I'm just trying to show that we're looking at these, conditionals are one of the primary elements of code. Variables are one of the primary elements of code. And so we're already basically coding here. We're looking and dealing with code the whole time. Now, this is convoluted, obviously. I don't expect you to understand all of this right now. But hopefully you see the idea that I have a color here. And then I have this other one here. So in my parlance, the black part are called frames, and the white part are called fills, okay? So with the Dyna Mandala, when it's playing, I am dynamically adjusting parameters in this material, and the effect of those parameters is being directed to certain parts of the mesh based upon the creation of this tree. So you can have more direct interaction with this. I'm going to now go in here to the same place we were at. I'm going to go up to the SETI class in materials. And there is here the SETI visualizer material. I'm going to double click that. And that looks a little bit different, but it's actually the same thing. It's a little less confusing because we don't see the wires going everywhere, right? The wires going everywhere is the way it's been for the most part. This now is utilizing a new feature called a named reroute. So that's what this is right here. I can drag off of this, and I can create a named reroute. I think I can create new. Anyway, I've got a bunch of them that I made, but basically, if it says fill RGB, and then I go over here and my color sum has fill RGB coming in, it's just a way to make it a little bit easier, not to see the wires stretching across each other and confusing where the connections are, okay? So this is a little different looking than this one, and that's because I built this new one more recently and the other one is old. Now, looking at this tree, I want you to go ahead, if you're going to follow along with me. There is, next to this, there's SETI Visualizer Material, and then there's SETI Visualizer Material Instance. Okay. So we've seen the way that we can isolate certain areas. And we've seen that UVs are used to multitask shaders. Oh, also another important part about this. By having a single material or shader which has the black and the white in it, I only ever have to load that one material for each object. If I had a separate material for the frame and a separate material for the fill, that would invoke what is called a draw call, as it would start to load the maps it needs for the fill or load the maps it needs for the frame. So by merging the two meshes together and using the UVs to separate them into distinct areas, it's a really bitchin' optimization. Essentially, it's twice as fast for the computer to do that kind of stuff. And so one, this is a good optimization. And, you know, I also don't have to manage as many things, you know, so it's more straightforward, really. Okay. So then, here's the one I was talking about that is, right. As we look at this, this one says mesh particle mat. This is the one that's being used in the Dynamandala. This one is SETI Visualizer Material. This says particle color, but this says base color, see? When I use, this material has special dynamic parameters, particle color, and then basically this is just another version of the same thing. But these are specifically for having a line of communication with a particle system and a material. Okay, so that's why I made this second version that's here and for our demonstration, because you can, you can't change this value in the particle one, right? Like if I go up here and I click on this, there's no color to set, okay? That's because this is a specialized node meant for particles where the particle system is going to send that value. This thing only talks to particle systems. So I made this other version that's more like the first material we saw, where we can click on this and set colors ourselves and stuff like that. It's just more directly interactable as we're looking at it, right? Materials, instances, and parameters. Okay, this is a very crucial topic that also relates to objects as well. The master material is the base material created, the template or recipe. That is this file with all of this graph work where I dragged things in, and I wired them together, and I gave them names, and I made sure it was all hooked up right, okay? Then what I can do is save myself some trouble by creating a special copy that retains the structure of the base material but allows for customization. And so here you can see the base material that's blue. Here is a material instance. It's the same shader, but I changed what the color was. Now, two things for this. This shader we've duplicated is like nothing, right? There's 3 nodes going in there. I could show you shaders that are, you can't see them all at once because the graphs are so big. So the idea of building a complex graph and then being able to make an instance, a material instance of it that duplicates all that work we've done but allows me to customize it is a very important principle of all of computers, and it's basically called inheritance. We'll see it in a more specific application with objects, but it's the idea of creating a copy so that I only, if I wanted to now, in my material instance, have the ability to have ice start forming on it or something like that, well, I go back to my master material, build all the ice logic into it, save it, and now all of my instances would gain the ice logic stuff in it too. And it's the same thing we do when we're creating these interactive objects in the world and stuff like that. We write it once and use it many times. So if we go back to the original, and yet the values, the variables in the material, you don't want everyone to be customizable, because a customizable value is specifically called a parameter. So there were constants, which basically, if I go in here and I say, well, this now is a parameter because I changed it. But if I go here and I just say 4, so I get a value, and I dial in a red, and that's all good, and I use that, that is a constant. That will always be red. In a material instance copy, I will not be able to change the color. So I have to identify, but some values I know I want to be constant, because they're part of just making my code work. And some of them I'm going to want to allow people to change. This also brings up what a term called user-exposed variables. So basically, it's just things that you give the opportunity to change for the user to mess around with. In the Unreal Engine, these are called parameters, okay? The entire Dynamondala particle system has a gigantic list of custom parameters that I added to it. And parameters are specifically values that can be addressed via code, right? So and it takes more memory to build a bunch of parameters. So you want to say what you want to be constant and what you want to be parameters. Plus, you want to control what you expose to the user. You don't want to give the user so many controls that they can screw stuff up, right? It's a balance of optimization, but also ease of use, okay? So so this was a constant. I can click here and say param and find a vector parameter. There's other ones and stuff like that, but easiest thing to do, I take my constant, I right-click on it, and I say convert to parameter. So now that's the same kind of value, but it is of a special kind that when I instance this material, I'll be able to customize it. So let's look at that a little bit more. If we go back here, we have the visualizer material I was talking about, and then we have the instance. And so if I right-click on this, now you see I don't see the same thing. I don't see the tree anymore. I do see the ball, but I don't see the same thing. But over here, I have things that I can customize. And right now, base color is checked, and so I can change it. So I can click on this, and I can make it yellow, or whatever I want to, right? So now that is something that I can change on a per instance basis. So I can make another material instance off of that one, and take this guy, and so now, notice that was checked in that one we opened up earlier because I'd messed with it earlier. This one's not checked. This is a Boolean. Remember we talked about Booleans, true or false variables. There's no new variables, there's just Booleans and ints and floats, and they just get used over and over again in different ways. So here we're seeing a Boolean again, and what we're saying is, are we gonna change this parameter or not? No, we're not gonna change that one, but I'm gonna change this one. So I'll take the frame color and change that to something else now, right? So we're seeing Booleans as far as this is really turning parts of the code on and off when we do that, and then giving me the ability to customize. So now you're seeing me make an instance of this and change these colors dynamically, right? I'm doing that on an interface level by grabbing it and moving it and things like that. In the Dynamondala and any place else. So what this is then it's called a dynamic material instance. Dynamic meaning it can change while the program is running, okay? So it's a material instance that I can go and customize variables for and things like that. So I could basically make a basic shader for car paint, let's say, right? One car paint shader, and then I can have a whole bunch of different cars, and I apply the same shader to every one, but then in each case, I open up the shader and I change it to blue or purple or red or whatever, right? That's manually doing it. Later, I can have a car as an object with a dynamic material instance in it, and then a parameter for in the car that sets the color, okay? And that's going to be, I'm coding that then. Like I'm doing it manually now, but I'm making it I'm making it variable, and I'm making it possible to talk to it with code. So this is what I'm trying to do, is talk about all this stuff in the manual operation so that we'll keep that in our head so that when we get into coding, it doesn't seem like mythical magic. It's like I'm just tweaking that dial. I'm just doing it remotely. So is the idea of the template, which is the first graph that we make of the code, and then the copy of that is called an instance, which doesn't require us to start a new file and build a whole tree, but allows us to use the existing tree and the ones that we have put in the tree that says, when we instance this, these are parameters, so I'll be able to change those, okay? So it's that master object, and then the special copy of it called an instance that takes its structure with us. Because that's exactly what we do with blueprints later too, is we instance from the code that we wrote to the objects in the world that we can then manipulate parts of. So this whole thing about the material editor is one, because materials are bitchin' and you should know about them and exploit them as much as possible. And two, it's a really good place to start looking at the idea of instances. So yeah, so now we can go ahead, if you wish to, take a look at this thing. I'll take that instance and I'll put it right there. And so now it's got that look to it. And it's still limited on a certain level though. See, it's getting the changes that I made to this instant. If I go and I change this to another color, then it's going to change this one, right? So there's one instance, and I could apply the blue-black instance to all the things that I want to be blue-black, and I make another instance for the red-black or the, whatever, okay? But later, we're going to actually create a dynamic material instance that goes with this individual object that I can then talk to in code and have it function independent from the others in the world. That'll make more sense in a second, okay. Okay, instancing. The dynamic material instance is another name for an instance material when we create it. We'll see it coming up. So the Dynamandala uses very simple shaders with dynamic parameters. And yeah, that's it. And so you can play with these if you want to, but so a proper setup of materials is crucial to be able to complete them, to be able to control them via code. So another thing to realize is that once I have a parameter that I can adjust, then I can just start writing code that adjusts that value and the thing will work, kind of thing. So getting the ability to adjust a parameter in your interface and have it affect the thing up there, that's a big part of getting your code to work in the first place. And because there can be much more complicated chains for, there's something called arrays that we're going to deal with. Arrays are a group of things. You can, and it's generally a list, right? The list has index numbers for each entry in the list. So with the Dynamandala, I've got, say, a circular arrangement with 10 layers in it, okay? So I make a 10 spot array, and I put a color into each spot of that array, one for each layer of the mandala. And I adjust that color a little bit for each step. I have a component that will step the hue or the saturation or the brightness a little bit with each one. And then the material, the Dynamandala has a way to go, and row 10 is going to get spot 10. Row 9 is going to get spot 9, et cetera, like that. So then it's always looking to that spot, and I can manipulate what's in that array, and it'll change. And then there's sound. So we were talking earlier about meta sound and stuff, and this is, the sound system that's in Unreal is nuts good. I've barely touched it. Somebody I was talking to earlier, Max MSP, basically there's an incredibly robust sound system that has just come in to the engine that can do crazy weird synthesis, and it's all completely controllable by the engine and stuff like that. And I barely use it, poor sound. Every sound engineer you talk to on a game will always tell you about how he gets the last amount of the budget and the last amount of time to work on it. And one of my favorite quotes that George Lucas did a long time ago is special effects or visuals are 90% sound.
Oh, yeah.
You know? It's really incredible what sound can do, and it's sad how much it kind of gets left to the end, which I did too, but there's a really incredibly good sound system within it, and it's basically like audio shaders. So what we've been looking at with shaders and material creation right now is very relevant to the way that sound can be constructed in here too, and it has parameters, all that stuff. Okay, so I want to go a little bit farther with the material editor here. You can follow along if you like, or not. I'm going to do it in front of you here. Right-click in the empty space of your content browser in that folder, just like you're going to, in a regular computer, make a new folder or something. All right, so go ahead now with your material opened. Here's some more cool stuff you can do. If I open up that drawer again and I go down to the textures folder, there's also this thing called effects textures that I've got in here, which is a bunch of cool tiling textures that are good for effects and stuff. Pick any one that you want to. I'm going to grab this one. So notice that I'm just clicking on it and dragging it into my material editor. And see how that put that into the scene? Okay? And now I grab this off of here, off of RGB, and I connect it to basic color. And now we see our texture on the surface of our object. Right? Okay. See here on the left it says UVs. And you can actually have different UVs for meshes. I won't go too much into it, but you can. Yeah, no, you can have a UV layout for, say, the color channel, and then you could have a different UV layout for another map that you want to apply in a different way. Yeah. So you can just have multiple UV coordinates on a vertex, and that allows you to do the kind of coordinating that I did before. And that's why I just wanted to mention the fact it says 0 here, right? So you weren't like, why does it say 0? Basically, the default UVs are the 0, are the first ones. So I'm going to right-click. I'm going to type texture. And you should quickly find out this one called texture coordinates. Okay, so click one of those out. So now this node is called the texture coordinate. And drag from that wire into UVs right here. Down here, I'm going to click on this little box. You can basically change what sort of object your preview of your material is. I'm going to change the box just because it's really easy to demonstrate this now. And I have the texture coordinate going into here. And you can see that this says 1 and 1 right now. And that basically means it's going to be complete. So if I go and I change the U tiling to 2, now it's doubling that texture horizontally. Okay, I could change it to 20. Right? Okay, so I could also change this one to 20. And now I get them all tiling at a very high rate there. Okay? The whole point of this is these numbers are going in here and manipulating the way that this texture is applied to the surface, okay? So I'm going to put them back to 0, 1, and 1. If I did 0 and 0, then it's just going to be a solid color because I basically stretched the whole thing across. I could do 0.5, and now it's 0.5 horizontal, but it's 0 vertically, so we see those weird stripes. I could do 0.5 by 0.5. So the whole point is that this value is coming in and manipulating this part of that. Now, yeah, let's just stay there. Okay? So I'm going to set these back to 1 and 1. And now I'm going to right click again. I'm going to type panner, P-A-N-N-E-R. Notice that when I type panner, it says coordinates above it. This panner is in the coordinates category. So as you type in things, it will show you different context relevant options. So there's a certain amount of filtering of all the nodes that you can choose from based upon the nature of what you're using. So this is a panner, and what this will do, I can take this and I will plug it in here into the, I will, where it says coordinate, I need to pull this back a little bit now. And we're going to set this right into there, and then this right into there. And so now, same difference, no big deal. I can still go here and change these values if I wanted to, okay? But now we have the ability to make this thing move, but we need something to drive it. And so that's going to be time, T-I-M-E. So basically, time is just a number that's going up so that you get an impetus to make things move, okay? We will not use time very much in the Dhyana mandala because time is almost like tick. It's just this ongoing value, and we want to be able to trigger things a little bit more. Time is just running, but for this example, it will work well. So I take time and I drag it into the time spot. Still nothing has happened because I've also got the speed values. So now if I take this and I set it to 1, and now it's moving. So we're animating the UVs in the material. It's a little weird because we were putting the UV values on the meshes and stuff like that, but basically the important point here is the idea of variables that are going in and manipulating data, right? This is programming. This is programming right here. And I can go even further with that and say, drag off of this, and I'll say make of float 2. Okay, a float 2, it's just another form of two values put together. A float 2 is two values put together. So now I've got this thing, and I can click on this, drag off. I'm going to right click on this, and I'm going to say promote to parameter. So, and I can, and it gave me that name, and I'm going to call it X speed. And then I'm going to right click on this one and say promote to parameter, and call that Y speed. Oops. So now I've got two parameters that if I set, we'll be able to control the scrolling of this texture. What's up? So, say that again. This one or these? These, I right click on the thing and I say promote to parameter, which isn't there now because if I disconnect it, I right click on this and I say promote to parameter. When it's empty, when it's an empty pin, I say promote to parameter. Yeah?
Does make float 2 have any function out without promoting those two variables to parameters? Does it do anything?
I don't think so. That's why I was wondering about that. Like if I do make float 2, yeah, it doesn't like have the ability to enter data in here. So it seems to really be built around sending parameters into it. So one of the important things to see about this, though, too, is that when I right-click on it and I say promote to parameter, it makes me a single value scalar parameter, okay? If I go up here and I drag off this, or if I right-click on this and I say promote to parameter, this makes me a texture object parameter. So the important point is that as I click on the pin, and I say, make me a parameter for this, it understands the kind of parameter that I need to go in there and makes the right kind of object. If I were to go here and say, give me a custom, I don't even know what this is, per instance cube data, right? And now I disconnect this and I try to drag that thing in there. See how it shows me, no, this isn't gonna make any sense. What, are you crazy? So sometimes it can be hard when you're trying to build something to find the right node that you need to go in and stuff like that. So this is part of something that's built throughout Blueprint as well, where it will give you the right kind of variable if you approach it in this way. So you can use its wisdom to help you. So I'm going to go ahead now, see if I put texture into there as a parameter and I get rid of this. Put those into there, X speed and Y speed. Clean this up a little bit by deleting that, and I say save. So this is new material 1 that I made, and if I go now into our SETI materials folder, and I go to new material 1, which I can see moving, if I right-click on it and say create a material instance, this is how you make an instanced version of your master material. And notice it automatically gives it the name new material 1 instance. Okay? Now if I open that up, I've got X speed and Y speed as parameters that I can manipulate. Wow, it's weird. It's not showing them. It's just, you know what, that's what I need to do is go here and say real time. There we go. So now I can change those values and mess with them, okay? Everybody with me? Okay. Why does that matter? Stefan, what are you after? So here are these objects. Here is this sphere that I dragged the texture slide basic material onto, okay? Now if I go into the details panel for this sphere, I can set its position in space, I can set its rotation and stuff like that, but I can't change those tiling speeds. I can't change the way that it's moving. It's not available to me because this is just an object in space with this material on it. However, if I click on this one here, I've actually got individual value settings here that I can do to move them around. And I can even change what texture is on here. I've got a texture as a variable, so I could go in here to our FX textures and put, running on this small screen's a little hard, there we go. So I can go here and I can grab any of these textures I want to and drop it in there. And you guys have this material in your thing. So now we're seeing a different texture. This is a blueprint, this sphere. This is not just a sphere I dragged in the world and put a material on. And we can see that if we go look at here, we can see BP standing for blueprint, UV slide, edit blueprint, UV slide. I can open that up and now we can see, yeah, and here's the viewport where I can see the object in the world. Remember this I was saying, the viewport is where I can look and see what's going on. It's the construction script where I've done all of this coding that is giving me things like texture assign, which is an instance editable variable. If you look at it over here, you see the eyes are open on it. That means it's something that is available for the user to change. So if I go back into this world and I look at this thing, I can see that I can choose what mesh should be in there. So if I were to go grab, how weird can we make this? Props. I could drag this static mesh into here, and now I've got a chair with a, I don't know if it's got a, maybe it doesn't like my shaders. That might have not been the best improvisation of the night. So anyway, the point is, these are now changeable things because this sphere has been wrapped inside of an object. Object-oriented programming is the way in which we build things that we can interact with in the world and have values that you can manipulate, and ultimately have values that you could manipulate not only manually but also programmatically in your code. Okay? So objects are a way of organizing code based upon the real world things that we deal with. Objects allow interactivity. Most game engines use object-oriented programming, Unity, everything. As I said before, it's because object-oriented programming performs very well. It only kind of starts responding to your input and things like that as you interact with it. Define once, use many copies. So if you look at here again, you know, here's that same thing with the Earth map put in as the texture, right? And here it is with another image put in the texture and some different values in the panning, right? So these are the same object. These are unique instances of that object with user-changed variables. Yeah, Victoria, you with me? Okay. So the point is, I wrote that object one time. Now I can drag it in the world as many different places as I want to, and I can customize each individual instance of that object in the world. That whole architecture of having everything wrapped inside this volume and giving me the ability to manipulate stuff, that's an object. That's what the Dynamandala is an object with a particle system in it and a whole bunch of logic and a whole bunch of parameters that can be manipulated by the input from my MIDI machine here. So we'll go a little farther when talking about objects now. And this is going to be how we end up, is just talk about objects, and we're going to be done for the day and think on it all. So in Unreal, objects are called actors or blueprints. You're going to hear the term actor a lot in Unreal. You're going to hear the term blueprint a lot in Unreal. And that's what we're talking about.
So you make the materials you made an instance, and then it's also the sphere. That's another instance too.
Yeah, so the idea of instancing is ubiquitous. It's all over the place, right? So the material, I'll actually I can show you. Because that's a good point, Pam.
I'm just curious if you change the master, do all of the instances?
Yes, and that's the power. You write your master once, and then if you decide you want to change it, you can change it in the master, and everybody else will get updated. So you won't have to go update every single one. That is hardcore what object-oriented is about.
Okay, so in a follow-up to that question would be, so say you've got all your instances and you change your master, but each of your instances has a slightly different thing on it. Would that slightly different thing also apply?
It should remain unless you change the master so it's invalid.
Oh, that's
Yeah. Oh, yeah. It's sick. It's so good. It's crazy how good it is.
So, like, if you had a red and a green and a blue one,
Mm-hmm.
they're all spinning in this way.
Yeah.
If you decide to change the master to spin in this way, they'd all.
No, that would be you'd have to go back in it. If you probably have to adjust. I mean, unless you change the math fundamentally, you know, it's.
I mean, you could set it so that set the spin so that the spin is whatever the master is, right? I mean,
Yeah. You could go to defaults. Yeah, don't go there. I know what you're talking about, but don't go there. You write it in the master and you get it in the instance. And then you set the individual setting on each instance. If when you change the master, you don't invalidate what's in the instance, it'll still just be whatever you did last.
Got it, if it doesn't invalidate.
Yeah. Well, that'd just be if you change the architecture. You would know if you were doing that. You don't go change the architecture of your master without intentionally, okay, I'm going to change everything now.
Okay.
So, oh yeah, I know I was going to say, also, so if we look at, come on, stupid computers. So actually, in the code for this object, this is that object that we're dealing with, in the code. So over here on the left are the components of the object, the data of the object, the geometry. I'm using something called an instanced static mesh in this case. It basically just means a static mesh. It's just one static mesh, but this is what I needed to do. So you see, I can drag this object. I attach this object by saying add, and I could say static mesh. I could say sphere. You know, there's all kinds of different things that you can add in here. There's many different components that you can add into a blueprint, okay? So the parts that you add in go here, the variables that you're creating are here, and then you use them over there. So I know I want to do something about the mesh that's in there, right? So I'm going to drag a reference to that mesh into my graph, right? So I know I'm talking to this object that's in my data structure. And so that's what I have right here. And what I'm doing is, the first node I'm doing is set static mesh. So I say set static mesh, and let's say I just did this again from scratch, let's say here, set static mesh, yeah. And notice this doesn't have anything in it, right? Down here, you don't see it looking like this. I could choose a static mesh this way, or I can right-click on this and say promote to variable. When I promote this to a variable, watch over here on the left. Boom, here's my new variable. New mesh, we'll just call it new mesh right now, right? So this is now, if I click on this variable and inspect its information, I can see over here on the right, see this is the details panel for what I'm selecting. This is a static mesh variable, okay? Then when I say instance editable, notice the little eyeball opens over here on the left. That means this, when I drag this blueprint into a level, this will be available for the user to change, okay? So I just put those in here for the sake of illustration, but they already exist right here. And you can see it when we go in here and you see that we've got the ability to define a mesh. We've got the ability to define a texture and the pan speeds and things like that, right? So back here in the UV slide, we can see that from the instance static mesh, I create a dynamic material instance. So this is where you guys were asking about making the instance of the material. So this is a special node that takes whatever material is on the object and makes a dynamic copy exclusive to this blueprint. And now I can talk to that one and change color and change these values and stuff like that, and it'll be just the one that's on this object. It's not like when I clone them around and I set each one individually. So that's how. So it's part of the process of setting the thing up. And then farther down here, I've got the material that I made. Now remember, we built this material with an X speed parameter and a Y speed parameter and a texture parameter and stuff like that. So once I have this reference to the instance of the material for it, I can also then adjust these values, like the X speed. And see, it says set scalar parameter value. That's what you call the kind of parameter that we put in that was adjusting the U and V speed. And so by having a reference to that material, I'm going to set the scalar parameter value. I put the name of that parameter I want to manipulate in there. And then I can attach a variable to it so that I can set it. That was a lot. I know that was a lot. I hope you generally got it. We don't need to hear all of that because I want to go back then to what we're talking about, which is. Okay, back to objects, because this is really what we're trying to talk about. Because object-oriented programming in Blueprint, they're called actors or blueprints. So once again, actors, objects, blueprints have the subject of data versus functionality. Okay, data is something. It's the 3D mesh, an animation, a location in space, a size, a duration, color, speed, things, right? Functionality does something with the data. Okay, so functionality is what we do in our graph. It's the ability for me to have a slider in the details panel that I can adjust and will change something about the object. So data and functionality, but there's nothing else I need. That object, if I drag it into the world, then when I look at its details panel, it'll have these values that I can address. And I won't have to use any other program to talk to it to set those things, because it's self-contained and it's autonomous, right? Everybody with me on that? Cool. So blueprints are a combination of data and functionality into a singular entity. Blueprints are objects. That's exactly, data and functionality into a singular entity is what you would find if you go look up object-oriented programming and objects on the internet. Okay, here's one of the terms that I really, really want to demystify right now, which is class. It makes sense to me now that I've done it for a while, but class is, from the traditional object-oriented programming world, the name for writing an object. When you're writing the code that would define an object in text-based coding, that file you create is called a class. A blueprint really is a class, okay? A blueprint is defining how we're going to build this. What are the instructions for every time that we drag this blueprint into the world? It's going to, at that instant, create a version of that from that instruction in the world. One blueprint that you write can be dragged many times into the world to create multiple instances of that blueprint. The instances are the objects. The class is the recipe or the template, or again, as we were talking about earlier, the cookie cutter, okay? So the class is the cookie cutter, it's specific and it's gonna be, and then when you go stamp it in the dough, you get all these different cookies. In the computer, the dough is your RAM, okay? So when you say, make me a float variable, call it this, the computer goes and builds a little box in your RAM and names it whatever you named your float and keeps a value in there. This is the part where I say that coding is absolutely physical. When I drag things into the world, the computer is going and cordoning off a little room in our RAM to keep that object, and to be able to have inputs to its parameters, and to be able to have storage of its variables as they change over time and stuff like that. I have a jillion different variables in the Dynamondala, you know, it gets huge, and they're all kept within that object, and different manipulations on here will grab different ones, change them, and store them in there. So, does that make sense? The class versus the instance? The relationship between the cookie cutter and the dough is what's important here. Not that the dough could change. The fact that the cookie cutter defines the shape of the cookie, and every time you use that cutter, you're going to get a cookie of that shape. If you want a different cookie, you'd use a different cutter. Okay? But it's always out of the same material, which is the RAM in your computer. Look at this here, the car, right? The car is our root class. It has acceleration, it has steering, it has reverse, it has brakes, let's say, right? You can then, so the idea, so the first of all idea, this is another kind of restatement of just the customization. You could have a car class, and then you could say that you wanted to make it red, you wanted to make it blue, you wanted to make it a Ford, a Toyota, right? So these are individual things. So really, there's something called inheritance. So when we talked about instancing the materials and the structure of the material came over, but I didn't have to look at that grid anymore, I just would have the parameters I would adjust, right? It was inheriting that graph structure into the instance and letting me change these things. So one way that's really commonly done with object-oriented programming is to write only the minimal stuff you need at a base level, then instance it and add the things you need for your uniqueness. Like you could have a vehicle Vehicles go forward in space. But then you would make a child of this object. So it's just like making an instance of the, it's kind of like, it's not the same terms. It's kind of like making an instance of a material, but in this case, when you make a child, you get everything that was in the parent, and you can add more on top of it. And this is cool because you've got vehicle, and then you've got wheeled vehicle versus boat, right, that you see here. So we've got go forward, we've got turn left, we've got turn right, we've got fall out of the sky, whatever, in vehicle at the very top. And then we've got roll on wheels or slide on a hull in each of these individual things. We can add a little bit more specificity as we get to cars or bikes, right? You only write the vehicle part in the first one. Then you make a child of it where you add wheels in it. And the thing is when you make the child, it's as if you're starting with the first one. Everything that was in the first one is there. And this used to really mess with me because of the whole idea, well, I'll do it in the parent and I'll do it in the child and stuff like that. That can get confusing. When I realized that you're really getting it all at once is the important thing to understand. So if I make, a child of this, and then I make a child of that, and then I make a child, and I go to cars versus bikes, I get all the code that was in here. And it's not changed, and it's not special. It's basically, I just get a bigger file. But if we went back to vehicle and we changed something about its movement in space, then cars will get that, bikes will get that, and boats will get that too. So I can have what I know every single thing is going to want and write that in one part of the code and then do the other stuff. And then when I go, oh man, they all need to be able to hop. Okay, I'll go add hop in my parentmost one, and now all of them will have hop in it. So that's it for today. I think we've talked about using the Unreal Engine. We've seen what materials are. We've seen what UV coordinates are. We've seen positions in space. We've seen the idea of instancing materials with parameters in them so that we can adjust them. And we've seen the idea of blueprints of actors that have data in them and parameters that we can adjust, and the way that wrapping them in an object makes it something that we can do that with. So the next thing to talk about is coding, right? Like, how do we start writing code? And basically, that's all about what will go into the logic that's in our graphs, okay? So first, I just really wanted, and it's funny, a lot of, at least the things that I started with taught you what a variable was, and then what a float, taught you everything like going up like this, and then ended at objects. And this is one of the main things that I think, let's start with objects and this idea of orienting that, and now we'll start talking about what we fill in there. But as long as the idea of objects makes sense and this autonomy of them and their ability to be addressed, I think, well, that's the angle I'm taking. I don't know. Okay? Thanks.